Hello guys, welcome to this class. So in this lecture we are going to install the necessary softwares that we require to start coding and learn Java. So let's get started. So in this lecture we will be installing two softwares on our system, which is Java JDK, which is required to run Java, and IntelliJ IDEA, which is an IDE that will help us write and execute Java programs. So to install these two softwares, you'll first have to open the browser of your choice, and you'll have to go to Google, okay, and in Google we'll type in JDK download. So JDK is something that we'll install to get Java on our machine, okay. We'll click on this Java Software Edition Development Kit 8. So JDK version 8 is what we'll be installing, okay. And over here you'll see a list for different operating system. I will go ahead and first accept this license. So you have to first accept this license. Thanks for accepting. And then based on your machine, the kind of machine that you have and the operating system, you can download the corresponding file. So for example, if you are running Windows 64-bit, you have to download this file, okay, else you will download this file. Or if you are running a Mac, you will download this, or for any other system you will choose the corresponding file, okay. So if you don't know like which version of Windows you are running, you can right click on my computer on your desktop and go to properties, and you can see over there the operating system version, whether it's 32-bit or 64-bit, okay. And after checking that out, you can come over here and download the appropriate file. So just click on any of these, and if I click over here on the Mac version, okay, I'll be prompted to download this, and I'll click on save. But I won't do that as of now because I already have Java running on my machine, okay. So after you download this, okay, we'll again go to Google, and we'll look for IntelliJ IDEA download, okay. Now this is the website that comes, okay. Download IntelliJ IDEA, the Java IDE for professional developers. I'll directly go to this link, okay. So JetBrains is the company that that has built this IDE, okay, and they have a range of tools, okay. But so this is the page that gets loaded over here, okay. And so for me it's Mac OS, okay, but if you have Windows, this will be selected, Mac OS, and for Linux guys this will be selected, okay. So this is a cookie warning. I'll just cross this out, okay. Now there are two versions, okay. So I have the community version over here, which I have downloaded for myself, okay. And community version works fine, like to learn and run Java programs, okay. So we'll be using this community version over here, okay, to learn Java, since it's free and open source, okay. But it has limited features, okay, but I think we have enough features to learn and execute Java program, and that's important over here, okay. So you just download this file and just save it on your desktop, okay. Now I'll be showing you steps on how to install Java. So we'll be installing Java JDK first, okay, and then we will be installing IntelliJ IDEA, okay. So to install Java, you'll have to double click on the installer file that you just downloaded. So to start installing Java, you will have to double click the file that you downloaded for Java, okay. After you double click on it, a pop-up window will open, which will be something like this. So installing Java on your machine is relatively simple. It's very similar to the installation of any other software that you do, okay. So on this screen you have to make sure you note this path over here, okay. This path is something that we'll be needing when we open the IntelliJ IDEA for the first time. So this is the path where your system is installing Java on your machine, okay. Now you just need to click next, and at the end the Java will get installed, okay, and you will see a confirmation message, okay. Now after clicking on finish, you just need to navigate to C drive, programming files, Java, JDK 1.8 if you are on Windows, okay, and you need to just check for these two folders, okay, and this is where these are your Java files, okay, which just got installed, okay. Now after installation of Java is complete, you need to double click on the installation file that you just downloaded for installing IntelliJ IDEA on your machine. After doing that, you need to click on next and follow the installation instructions for IntelliJ IDEA. They would be really simple, okay. After the installation is complete for IntelliJ IDEA, and when you open IntelliJ IDEA for the first time, okay, you will see something like this, okay. So IntelliJ IDEA is asking me whether you want to import any settings from a custom location, or you don't have a previous version of IntelliJ IDEA, okay. So you have to just select this, I don't have a previous version of IntelliJ IDEA, okay, unless you want to import it, and just click on OK, okay. After doing OK, the next step will be, it will be asking you to set up some theme for your IDE, okay. So you can select the theme of your choice, okay. So there are two themes, one is like the normal white theme and another one is Dracula theme, okay. So after selecting the theme of your choice, you can click on next default plugins over here, okay. On the next screen, it will ask you like what different kinds of plugins do you want to install to configure your IDE, but we won't be installing any plugins over here, okay. And we'll be clicking over here like skip remaining and set defaults, okay. Now after doing this, it will ask you to create a new project, okay, and you just need to stop over here, okay. So creation of new project and how to get started using IntelliJ IDEA, I will be showing in the later lectures, okay. So that's about the installation and setup, guys. If you have any questions, feel free to reach out to me. Thanks a lot. See you guys in the next class. Thank you. Hello guys, welcome to this class. So in this lecture we are going to talk about classes and objects in Java. So this is a conceptual overview of classes and objects, and hence I will be taking you through some slides to explain the concepts of classes and object. Okay, in next lecture we will be doing some practical wherein we will be actually creating some classes and objects and understand this in more detail. So let's get started. So what are classes and objects in Java? So like you guys know, Java is an object-oriented programming, and it means it has to do something with the word object. So what are objects? So objects are anything that you see around you. If you look around in a room that you are sitting or wherever you are, you will see a lot of things like, for example, I can see a cupboard, I can see a dog, I can see a bottle, I can see my laptop, okay. So these are all objects in real world, okay, and every object has a state and a behavior. Now what does a state and behavior mean? So let's say for example, for a dog that I'm seeing right now over here, a state will be something like the number of ears it have, the color it has, the breed it belongs to, the total number of legs it has, the height of the dog, the weight of the dog, etc. Similarly, behavior for a dog will be walking, barking, sleeping, etc. So if you look at the definition of objects in Java, objects are nothing but instances of the class. It means objects are created from classes. Okay, and like we discussed, objects have a state and a behavior. So what are classes? So classes are nothing but a blueprint which is used to define objects. So in our example, to create an object for a dog, you will have to first define its class, okay. So in class you will define all the different states you want the object to have and all the different behaviors you want the object to have. So classes are also termed as a user defined data type. So in Java we already used some primitive data types, okay. We learned about them like integer, float, double, etc. So primitive data types have limited functionality, but if you want to build anything custom for yourself, classes is what helps you define a user defined data type in Java. But why do we need these classes and objects in programming? So classes and objects makes it very easy to simulate real world scenarios in programming, and classes and objects are the building blocks for object oriented programming. Okay, so let's take a look at some real world scenarios as an example. So some real world scenarios that I have mentioned over here are user orders a food. Okay, student can enroll in a course, driver can drive a car. So let's see how we can simulate these real world scenarios using classes and objects. Okay, so we'll take the first scenario, which is the user orders the food. Okay, so now over here user can be any user. Let's for an example take a user John. Okay, he can order different kinds of food, which is burger, pizza, or a sandwich. Now over here in programming, John will be nothing but an object that has certain state and a behavior. Like John will be represented like this in programming. So like you can see, John has certain state like name, gender and age. Okay, and we have defined over here like name is John, gender is male and his age is 22. Okay, now John can have certain behavior like he can order food and he can update his profile. Okay, now this behavior John will be using to perform certain actions. Okay, similar to John, we can create multiple objects like William, Stacy, which have their own state and behavior. Okay, so the state will be name, gender and age like you can see. So these are multiple objects created using the template or a blueprint, which is nothing but a class. You can see that the user class has defined the states and the behavior that its object can have. So you can see like user class has the state name, gender and age, and the objects that are created using the user class has these three states defined in them. Okay, and the objects of the user class can exhibit two behaviors, which is the order food and update profile. Okay, now let's take a look at the user class. Okay, so this is what a user class will look like. Okay, so you can see like the states and the behavior defined. Okay, now the states can be defined using the variables. So a class uses variables to define the state for an object, and behavior is defined using a method. Okay, and these variables and methods are known as the members of the class. Classes can also contain interfaces, member class and constructors as members apart from variables and method. So in total a class can have variable, methods, interfaces, member classes and constructor. Okay, so that's about this class, guys. See you guys in the next class. In next class we'll be writing some program wherein we'll be actually creating some classes and we'll be actually creating some objects and we'll be understanding more in detail. So thanks a lot, guys. See you in the next class. Hello guys, welcome back. So in last lecture we had a conceptual overview of what are classes and objects in object oriented programming in Java. Okay, so in this lecture we are going to create a class hands on. Okay, and we'll be creating objects to exhibit certain behavior. Okay, so let's start by creating a class. So we'll be creating a class called car. Okay, and it will have certain variables defined in it, and it will also have certain methods which will define the behavior of the class. Okay, so to create a class, okay, so here I have already created a class called main, which will be my main class from where the program will be executed. To create a class, I'll be going to src folder over here in my project. I'll be right clicking over here, I'll be doing new, and I'll be selecting this option over here which is Java class. Okay, and I'll be naming my class as car and I'll be pressing OK. Now Java just created a file called car for me. Okay, So I'll start defining the variables for this class. Okay, so I'll start by writing the access modifier, which is the public. So we'll be defining the public variables, and it will have a model, a class car. Car will also have color. It will also have seat, the total number of seats that the car has. To define a behavior, I will create a method. Okay, so it's public. I'll just write a method that will display all the values of the variable it has. Okay, so I'll call this method as display. Okay, it won't accept any parameters. I'll define the curly braces. Okay, and I'll just write system.out.println model is, I will define the, will print in model over here. I'll just duplicate this, color, just color, I'll seats, and I'll print in seats. Okay, so we just created a class over here called car. Okay, we defined certain variables that this class can have. Okay, which were, so these all are public variables, and the variable names are model, color, seats. Okay, and it has a corresponding data type. Okay, like you can see over here, and we also defined a method over here that this class has. Okay, and this method will be simply displaying the values of all the variables that it has. Okay, now what we did over here is we just created a blueprint. Okay, which is nothing but a class. Okay, and we'll now be actually creating objects using this blueprint. Okay, so we'll be creating objects like Ferrari, we'll be creating objects like Audi, we'll be creating objects like, we can define say Tesla. Okay, so you can create different kinds of car using this particular blueprint. Okay, and each and every object that you create will have these properties. Okay, and it will also have this behavior. Okay, so let's take a look at it. So for creating objects, I'll go in my main class. Okay, and to create objects, okay, I'll just type the class name, then we have to write the object name. So I'll just write Ferrari. Okay, I'll put equal to sign, I'll write new class name again along with a set of parentheses. Okay, so this is a syntax, and this is how you create a object in Java. Okay, so you start with class, object name, and you use the new keyword. So new keyword is used to allocate memory to this particular object that you are defining over here. Okay, and you again write the class name and a pair of parentheses. Okay, and along with a semicolon. So this is what you, so you just created a object. Okay, now it's time to assign values to all the variables over here. Okay, so initially all these variables will be null. Okay, they won't have any values because you are not initializing it with a default value. Okay, so to assign them values, what I'll be doing is we'll start assigning from the main class itself. Okay, so just to let you know, all these variables that we created are public variables, and it can be accessed from the main class. Okay, so I'll be typing in the object name dot, and you can see the suggestions over here. So this is how you access the variables inside a particular class. Okay, so you type the object name dot, and the IDE will suggest you with seats, color, model. Okay, whatever you have defined over here, type in enter equal to, and you'll start assigning the value Ferrari F430. So this is a model of this particular car that we are creating. Okay, Ferrari dot seats, it has 4 seats. Okay, Ferrari dot color, so color we can define, let's say red. Okay, and what I'll do is I will simply be invoking that method that we have created over here, which is the display method, okay, that will print all the values. So to call the method, you will simply type in the object name dot display, okay, the ID suggests over here, you type in enter. So what you just did is you created an object Ferrari using the blueprint car, which is the class, okay, and you assigned values to the variables within the class, okay, and you are also calling a method over here, okay. So we'll just run this program and we'll see what the output looks like. So ideally this program should print all the values of this particular object that we have assigned, okay. So we'll just right click and we'll run this and let's wait for the output. And there you go, you see whatever we have assigned over here, okay. Now similarly you can create multiple cars over here. So like car, I can create a Tesla, okay. I'll use a new operator, I'll type in car and I'll just assign some values to it, Tesla. Let's say I'll call the model as model S, okay. I forgot a semicolon, sorry, yeah. I'll just say that seats it has is 4, okay. Tesla dot color, so the color it has is black, okay. I'll again create and I'll again display the values, okay. We'll create one more object over here, okay, car, let's say Audi, we'll use new operator, car Audi dot model, so let's say Audi, so the model name is SQ5, okay. I'll just create model dot color, I'll assign a value called blue, let's say it's a blue car, Audi dot seats 4, okay, and I'll display whatever we have assigned, okay. Now I'll run this program. So ideally this program should print the values for this Ferrari object, it should print the values for Tesla object, it should also print the values for Audi object. So let's see what the output looks like. So there you go, you are seeing it printed the value for Ferrari object, the Tesla object, and it also printed the value for Audi car, okay. So what we just did is we created a blueprint, which is a class, okay. We created some variables, okay, and a method, and we created 3 objects and we actually printed the value, okay. So this is what we just did, okay. We created a car class, okay. It had certain variables defined in it, model, color, seats, and a display behavior, which is a method, okay. And then we created 3 objects over here, okay, which is the first car, second car, third car. We assigned some values to all the corresponding variables and we used it in the program, okay. So that's about this class, guys, okay. See you guys in the next class. Thank you. Hello guys, welcome back. So in last lecture we understood like how we create classes and how to create objects, and we also created a class car, okay, and we created 3 corresponding objects, which is Ferrari, Tesla, and Audi. So in this lecture I'll be introducing you to the new keyword and I'll explain you the role of this new keyword in creation of the objects. So let's get started. So before I talk about new keyword, I want you guys to understand how memory allocation works in Java. Okay, so for the sake of explanation, I'll take you through this slide over here. So let's say you create a variable a, okay, and you have declared it as type integer, okay. Now integer has 4 bytes, okay. The size of integer is 4 bytes. Now when you declare this particular variable and assign it a value, what compiler does is it allocates variable a memory block which is corresponding to 4 bytes, okay, and if you are assigning a value 10 over here, this 10 sits in this particular block. Okay, now one point to be noted over here is every memory location in memory has a address associated with it. So in this particular example, this is the address of this memory location which is allotted to A. So if you have to refer to A, you have to use this address to refer to this particular memory block which is allotted to A. Okay, so this is how memory allocation works in Java. Okay, so these are some of the things that I want you guys to understand. So whenever you create variables, you allocate memory corresponding to the size of the data type. Okay, and every location has an address associated with it. Okay, now let's get back to the object creation. Okay, we created objects in our previous lecture wherein like we used the class name, we declared the object reference variable which is nothing but the object name. Okay, and after equal to we use new keyword and then we use the class name with two parentheses. Okay, so I would like to tell you over here that object creation has basically two steps. So over here we created objects in one step. Okay, in one shot we created an object. Okay, but object creation actually has two steps. Okay, which is like object declaration and object. So object creation has two steps, which is object declaration and memory allocation. Now what does object declaration means? Since in last lecture we have declared object and we have also created object in one statement, I will break this statement into two parts. Okay, so to explain this, I'll create a car test over here. Okay, and I'll put a semicolon over here. Okay, so this step, like wherein like we just declared the object name, is known as object declaration. Okay, so we just did a first step of object creation. Okay, then the another step is object name is equal to new test. Okay, so this is the second. Okay, no, not test, it's car. Okay, so this is the second step wherein the memory is allocated using the new operator. So I'll repeat myself, guys. So object creation has two steps. One is the object declaration, okay, and then the memory allocation. Okay, so in object declaration the name of the object is declared. Okay, now in this case we have declared the object name as test. Okay, so we have created the object of class car and we have declared it as test, and this test over here is also known as object reference variable. Okay, so this is the first step. Okay, so first step done, we just declared the object. Okay, now in second step the memory allocation for this particular object is done using the new operator. New operator is responsible for allocating the memory and giving it to test reference variable. I would like to also mention one thing over here, that when you just declare an object, there is no memory that is allotted to this particular object because you have just declared. Now in second step, when you actually use new operator, memory is actually allocated and assigned to test. So this means that after declaring the object, if you try to use it, it will throw an error. Okay, because there is no memory allocated to this particular object. So you can use the objects only after memory is allocated to them, so which is after the second step. Okay, now let's understand how this memory declaration and memory allocation works in Java. So to explain this, I'll go back to the slide over here. Okay, and so this is something that we did in our last lecture. Okay, wherein like we created a blueprint class. Okay, which is nothing but car. Okay, we declared three variables inside along with a method display, and we created three objects over there, which is nothing but first car, second car, and third car. Now when you declare an object, a reference variable is created in a memory. So for example, when you declare a Ferrari object, a Ferrari reference variable will be created in a memory. Okay, and after you use new operator, actual memory will be allocated with all the variables inside that particular object. Let's go back and let's break this Ferrari, since we are just talking about Ferrari object. Okay, I'll just break this into two parts. Okay, Ferrari over here. Okay, and I'll just put a semicolon over here. So So here, so what we just did is we have broken down the single line declaration and memory allocation of the object creation for Ferrari into two parts, okay, into two steps. So first we just declare the Ferrari object. Now when we declared an object of car, okay, which is Ferrari, okay, at this point a reference variable is created in the memory. But a point to be noted over here, after declaration, no memory is yet allotted to this particular object, okay. Only a reference variable is created in the memory with the name Ferrari, okay. Now when we initialize this Ferrari object with the new operator, actual memory is allocated for this particular object. Now, like we know, every memory has an address associated with it. So let's say this memory has this particular address associated with it, okay. Now this Ferrari object will have the reference of this particular memory. So what it means is this reference variable over here which we created, Ferrari reference object, this will point to the memory location of the actual object, okay. So this object has memory address of this, okay, and this memory address goes and sits into Ferrari reference variable. So what Ferrari reference variable is doing is it is just pointing to this particular object over here, okay, and that is the reason why this is known as reference variable, because this refers to a memory location of the actual object. Now whenever you assign any data, this data will be sitting in this particular memory blocks, okay, which Ferrari reference variable is pointing to, okay. And in similar way it works for all the other objects. So like in last lecture we created multiple objects of Tesla, Audi, okay, and these reference variables, these reference object variables were pointing to the corresponding memory blocks, okay, and data was stored in those corresponding memory blocks. So this is how object creation in Java works, okay. So now whenever you declare an object, a reference variable is created in a memory, and when you use new operator, memory is actually allocated to that particular object, okay. And how much memory is allocated, that depends on the number of variables that you have declared within that particular class. So like in this class we have 3 variables, so it also depends on the data type, okay. So since we have 3 variables and whatever the data type we have put in, according to that memory blocks are allocated. So this is how object creation works in Java, guys, and this is how new operator works. So new operator over here is responsible for allocating the memory over here and also to pass the address reference of this particular object, which is x0061x9 over here in our case, okay. So this address is passed to Ferrari object, and this is done by new operator. So new operator allocates the memory to the object, and it also returns the reference, memory reference of the memory allocated to the reference variable, so that reference variable can store that with it, okay. So this is how memory allocation works in Java, guys. If you guys have any questions, feel free to reach out to me anytime regarding this lecture. So thanks for watching, guys. See you in the next class. Thank you.
Hello guys, welcome back. So in this lecture we are going to take a look at some of the ways using which you can initialize instance variables. Okay, so basically you have created an object and the object has certain variables in it, okay, which is defined by the class, okay, and you want to initialize them. So what would be the ways to do so? Okay, by the end of this lecture, you will have a better understanding of what are the different ways using which you can initialize the instance variables, okay? And we will also take a look at each one of them with the help of an example, okay? So let's get started. So basically there are 3 ways to initialize instance variables, okay? The first one is at the time of the declaration. So whenever you declare a instance variable in the class, that is when you can initialize that particular variable. Second way is by using something called as method, okay, and the third way is from the main class using reference variable. So let's take a look at the first one, which is at the time of declaration, okay. So I have already created this particular project called as ways to initialize object. Okay, and I have two classes over here. One is the car class, which has certain variables in it, and a method display which displays this particular information. And I have a main class, okay, which doesn't have any code but a main method in it. Okay, so first method says at the time of the declaration. So what does that mean? Now at the time of declaration means here is where you are declaring the particular variables, okay, of the classes, okay, and here is where you can initialize them. So I'll call it Tesla S, or I can say model S, okay, color is red, okay, seats is equal to 4, okay. So this is how you initialize the variables, instance variables at the time of the declaration, okay. Now this approach is not recommended. The reason is, obviously you must have guessed it, that every instance you create for this particular class will have the same values that you have mentioned over here, okay. So just to give you an example, if I create an object of the class car, okay, and class car Ferrari, or let's say C is equal to new car, okay, and I have another car C1 is equal to new car, okay. Now C dot display and C1 dot display. So basically if I run the program, okay, so if I run the class, I'll see that both the object have the same values for their members, okay, and that is what you see over here, okay. So this approach is not at all recommended, but this is still a way to initialize the class members, okay. Let's take a look at the second method, which is using a method, okay. So basically what that means is you can initialize the class members using a method. So I'll will call a method over here, c dot initialize, okay, and I'll pass model S, okay, red, and I'll pass the number of seats, which is 4. Okay, we don't have this method over here, so I'll see a red bulb over here and it says create method initialize in car. I just click this and there you have this particular method created automatically by the IDE. Okay, this is one of the benefits of using IntelliJ. Okay, so we automatically have the parameters also defined over here. So it says a model, then red, and it says integer I. Okay, so I'm just going to initialize the class members with this particular parameters. Okay, so it's going to be model is equal to model S. Okay, it's going to be red, oh sorry, color is equal to red, okay, and seats is equal to I. Okay, and I'm just going to remove this default values because we don't need them anymore. Okay, and I will also, oh, I did a spelling mistake over here. Initialize, it's initialize, I missed A over here. Okay, and I'm going to do the same method call, okay, initialize for C1 as well. Okay, so it will be model S2, I'll just call it, okay, black, okay, and the number of seat it has is 2. Okay, and we are just then displaying both the objects. Okay, so what we are doing over here is we have created two objects, okay, car C and car C1, okay, and then we have called initialize method which accepts 3 parameters, which is model, color, and the number of seats, and then we have displayed this particular information. So I'll just run this particular code, okay, and let's see the output. So it should print these particular values for both these objects. Okay, oh, so we are getting null values over here. Model is null, color is null. Okay, let's see what's the reason for this. Okay, model is equal to model s, color is equal to red. Okay. Oh, so we didn't initialize C1. We actually should have mentioned C1 over here. Okay. And I'll just run this code again. So there you see the output. Okay. So we are seeing both the objects have been initialized with whatever parameters we have passed. So this is a way of initializing the instance variables again. The second way is using the methods. Okay. Now the drawback of this particular thing is it's definitely better than the first step. Okay, wherein we were declaring at the where we were initializing at the time of the declaration, but over here we are at least able to provide the values that we want for each and every instance. Okay, but the drawback over here is if you have to create 1,000 objects, okay, of a particular class in a real world project, then you have to write the 1,000 statements of initialization. So this statement you have to repeat every time you for every object. Okay, and this increases the length and the complexity of the code, and this is not a good programming practice. Okay, so over here only you must have noticed I did a mistake that I initialized uh, accidentally C over here instead of C1. Okay, and then we were getting null values when we printed C1. So these sort of errors are possible. Okay, and if the code is lengthy, okay, so this code is very short. Okay, and hence we were able to identify the error. But if the code is lengthy, then it becomes really difficult to figure out where the error is and what is the mistake that you have done. Okay, but this is a second way of initializing the member variables. Okay, class members, and let's take a look at the third way. Okay, which is from the main class using reference variable. Okay, so I'll just comment this code over here. So let's initialize the members of object C using this third step. Okay, so you have to like C dot, you have to do C dot model is equal to model s. Okay, then C dot color is equal to red. Okay, and then you have to do C dot seats is equal to 4. Okay, so I have to put a semicolon. Okay, so this is how you initialize from the main class using reference variable. Okay, now for this particular method, for this particular way, okay, of initializing the class members, okay, the member variables have to be public. Okay, which means that public basically means this particular variable can be accessed from anywhere. Okay, so if I change this public to private, okay, you compiler will immediately throw an error that private cannot be accessed from outside the class. Okay, so when you declare any variable as private, it just tells the compiler that the access for this particular variable is restricted to within the class. Okay, so I can access model within the class, but I cannot access model now from outside the class. Okay, and that is what private means. Okay, so I'll just change this to public and the error goes away. So this is the drawback of this particular method over here, which is the third method. Okay, which says that you can initialize the class members from the main class using the reference variable. Okay, so this particular object variable over here, car C, which is nothing but C over here, is nothing but the reference variable. Okay, which we are using to access its members. Okay, so there are 3 members this object has, and we are trying to access it using the dot operator. Okay, so this method is actually not recommended because the first thing is the variables have to be public for this particular method to be used. Okay, And also imagine now the length of the code if you have 100 variables over here. So if you are using a class which has 100 variables, you have to write this initialization code 100 times, which is not at all again recommended. Okay, it increases the length and complexity of the code, which is very bad for real world projects. So these are the various ways using which you can initialize instance variables. Okay, and I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to talk about what is constructor in Java. Okay, by the end of this lecture you will have a better understanding of what is constructor in Java and why you should use it. We will also understand how you can create your own constructor, and what are the rules that you are supposed to keep in mind while creating your own constructor. So let's get started. So I have already created a project over here, and we have two classes, which is nothing but car.java, which is a class of car which has three variables, which is model, color and seats. Okay, we have a function called display which basically prints all the variables inside this particular class, and we have a method called initialize, which basically just initializes the members of this particular class. Okay, and within the main class we have a main method. Okay, so let's talk about what is a constructor. So constructor is nothing but a piece of code which is used to initialize the object. Okay, so many tutorials online will tell you that constructor is used to create an object, but the actual use of constructor is to initialize the particular object. Okay, so let's understand on how you can what is the syntax to create your constructor. Okay, so basically constructor is created using a class name. Okay, so syntax is access modifier. Okay, then we have the class name. Okay, and then we have the parameters. Okay, and a pair of open curly braces and then close curly braces, and then we have here the statements to initialize. Okay, okay, so this is nothing but the syntax of a constructor. Okay, so we first start with the access modifier. Okay, this is optional. Okay, now access modifier is nothing but public, private, protected. Okay, and default basically. Okay, so public says that this particular constructor can be accessed from anywhere. Private says that this can be accessed only from within the class. So we already have a method which is used to initialize this particular members of the class. Okay, so we can use it in new car. Okay, and then we can call initialize to call model s. Okay, okay, and then I have color. Okay, which is red, and then I have 4. So this is how you can initialize the variables as of now within the class. Okay, using a method. Okay, but the drawback of this approach is if you have 1,000 objects to be created. Okay, so you have to write 2,000 lines of code. Okay, so one line is for the creation of the object and another line is for the initialization of the object. Okay, and if the code base is really huge, then it becomes very tedious and very confusing. Okay, and very complex to manage such a long code base. Okay, so to reduce the complexity, okay, is when we can use the constructor. Okay, so first we have to create the constructor. Okay, so I'll just delete this. Okay, and so constructor is created using the class name. Okay, so we have to write car over here. Okay, then open curly brace and close curly brace. So this is how you create a constructor for this particular class called car. Okay, and here we haven't defined any parameters, but you can define the parameters as string. So first parameter will be string, which is I'll call it a, okay, which is nothing but our model. Okay, or I'll call it model only. Okay, then then it's string. Okay, so color. Okay, and then integer seeds. Okay, now we have to assign this particular values to these particular member variables. Okay, so what I'm going to do is I'm going to use a keyword called as this. Okay, dot model is equal to model. Okay, now what is the use of this keyword over here? Okay, so if you notice that this particular parameter is name is same as the class member model. Okay, so if we just write model equal to model, okay, compiler will be confused that which is this model and which is this model. Okay, or so it will assume that both are these parameters and you are assigning a parameter to a parameter. Okay, so to specify, to tell the compiler that this particular model is not the parameter, but this is actually this particular class member that we have defined over here, we have to use this keyword. Okay, then we replicate this for all the other members as well. Okay, so this dot seeds is equal to seeds. Okay, now so this is how you create a constructor. Okay, it's basically the class name. Okay, the list of parameters followed by the pair of curly braces. Okay, which has the code of assignment, wherein you can assign the values in the parameters that you are accepting from the user onto the member variables. Okay, so let's hop on to our main class and let's see how you can invoke this particular constructor and initialize this particular variables over here. Okay, so I'll hop on to our main class. Okay, so over here so it's throwing an error over here. Okay, it's saying that there is a list of arguments that is expected over here. Okay, within this round brackets. Okay, so these parameters which you have defined over here are supposed to be passed while declaring the object which is over here. So I'm just going to mention Tesla. Okay, model S. Okay, color will be silver. Okay, and the number of seats are 4. And the moment you mention this, you see the red warning has gone away. And now we'll call the display method. Okay, and we will run this particular code. So you can see over here that whatever we had passed over here is getting assigned to the particular object. Okay, and you can also see that the code is very clean and neat. Okay, so basically there are just 2 lines of code. Okay, which is so first line, it declares the object, it creates the object using new operator, then it also assigns the or I should say initializes the object. Okay, and then we go to the second line and we call the display function, which displays the operates the information of that particular object. Okay, so constructor is definitely the best way to initialize the object. Okay, it not only makes the code cleaner, but it also tells the programmer that you are supposed to initialize the object. Okay, when you are creating it. Okay, and this is really helpful when you're working in teams. So imagine like I am working in a team. So I'm one engineer in San Francisco, and there is another engineer working on this particular class, and he's based in Dublin, which is Ireland. Okay, so now suppose he creates a object of this particular class car. Okay, car c1 is equal to new car. Okay, he has not checked the code of the car. Okay, and he's trying to create the class. Okay, now when he creates this particular class, Compiler immediately throws an error that, hey, you need to pass model, color, and seats over here. So model is string, color is string, and seats is integer. Okay, and without passing this, you cannot create this particular object. Okay, so basically we are making it compulsory for the programmer to initialize the object at the time of creation. So he has to compulsorily pass values over here. Okay, and he can pass it based on his requirement. Okay, whereas if you're using a method to initialize the object over here, okay, programmer has to explicitly remember, okay, so he has created this particular object over here. Now he also has to call that particular method over here. So he also has to call this particular method and pass the variables over here. Okay, so if he forgets to do that, it's a mess. But over here, in this case, compiler itself is reminding him that, hey, you need to pass the values. Okay, so these are the benefits of using a constructor in programming. Okay, and this is definitely the best way to initialize the object that we create. Okay, now when you use a constructor, there are some rules that you're supposed to keep in mind. Okay, so the first rule is that the name of the constructor should be same as the name of the class. Okay, you cannot give constructor a different name. So if I try to give it cars, okay, I'll immediately get an error that this is an invalid method declaration, return type is required. Okay, so compiler thinks that you are trying to create a method and not a constructor. Okay, and hence it's throwing this particular error. So the moment you remove s over here, the error goes away. Okay, so the name of the constructor should be exactly same as that of the class. Okay, the second rule says that constructors don't have any return type, not even void. Okay, so you can see our constructor over here, which is of the class car. Okay, so it doesn't have a return type. If you try to declare a return type, okay, so I write a void over here. Okay, you don't get a compiler error. Now can you tell me why aren't you getting a compiler error over here? Okay, this is a rule of the constructor, that constructor is not supposed to have any return type. Okay, so the reason you are not getting an error over here is because compiler is treating this particular thing over here as a method declaration. It's not treating it as a constructor. Okay, and you can verify this by going to main class, and you see the error over here that you cannot pass these arguments in the car class since there's no constructor. Okay, but yes, you can definitely call car method over here. So car becomes a method now. Okay, and you have to define variables over here. Okay, so compiler is treating this particular declaration over here as a method. Okay, so I'll just remove this. Okay, and the error goes away. Okay, I'll delete this code as well. Also, constructor doesn't have a return type because constructors are used to only initialize the object. Okay, but not return any value. Okay, so these are the couple of rules associated with that of the constructor. Okay, so in this lecture we understood what is constructor and why you should use constructors while programming or building softwares. We also took a look at one of the example wherein we created our own constructor. Okay, and learned how to use it. We also took a look at some of the rules that you are supposed to keep in mind while creating a constructor. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to understand what is method signature in Java, and by the end of this lecture you will have a better understanding and clarity on method signatures. Okay, and we will also understand how compiler resolves method calls for the execution of the program. Okay, so let's get started. So method signature is used by the compiler to resolve method calls. Okay, and it consists of two things. Okay, so the first thing is the method name. Okay, and another thing it consists of is the data type of the parameters, okay, of, okay. So let me give you an example for this. So let's say I have a method over here, let's say public, okay, void display, okay, and it accepts one integer, okay, as a parameter, okay, and I open it, I perform some operations over here, okay, some code over here, and I close the brace. Now the method signature for this method will be display, okay, and it will be int. So it has method name, okay, which is this, okay, and then it has the data type of the parameters, okay. So this is nothing but the method signature for this particular method, okay. Now if your method has one more parameter over here, okay, let's say this method accepts integer I and float f, okay. So the method signature for this particular method will be, okay, display integer, and the second parameter is of the data type float, so it will be just float, okay. And this will be the method signature in case of two params, okay, means two parameters, okay. So this is what a method signature is in Java, okay. Now method signature is used by compiler for resolution of method calls, okay. So what compiler does is whenever you declare a method, so let's say you have declared public void display, and then you also declared, okay, public void m1, okay, and this is the second method in this particular class. So there are two method, okay, one is this, okay, and the second method is this over here m1, okay. Now what compiler will do is it will create something called as method table, okay, and it will store the method signatures of these two methods in that particular method table, okay. And this is what it will look like, okay. So display int, okay. So this is the first method, and the second is m1, okay, with no parameters, okay, and it will create a table sort of like this, okay, and it will use this particular table for the method resolution, okay. So whenever you do a method call, it will look up for that particular method signature, and it will resolve those calls, okay. Now if compiler doesn't find a method signature for any of the method, it will throw an error, okay. And it will also throw an error if you have declared two method with the same signature, okay. So if I declare two method with the same signature as m1 over here, okay, m1, so this is not a valid thing, okay. So compiler will immediately throw an error, and the reason for this is compiler won't know, okay, which method to call if you are calling m1, okay. So if I call m1 over here, okay, like this in our code, the compiler won't know with which method of these two is supposed to be called, okay. So I'll give an example of this, okay. We'll hop on to our compiler, okay. We already have a method display defined over here, okay. So what I'll do is I'll do public void display, okay, again, and I'll just put two curly braces, and we immediately see an error, okay, that display is already defined in class car, okay. And once I remove this, the error goes away, okay. So the reason for this is because whenever compiler creates a method table as discussed over here, okay, uh, two same entries for this particular method is created over here, okay, and compiler is not able to resolve which method to call, okay, from the code, and that is why it throws an error, okay. Now one point to be noted over here is method signature doesn't have the return type of the method, okay. So return type is not a part of the method signature, okay. So if you have two methods which with different return types, okay, the signature for both will be same, and hence they both can't be there in the same class, okay. So let me hop on to the again. Now I'll try to define display method with a different return type, okay. So void, okay, int display, okay. So you can see over here, okay, sorry, not void, public int display. Okay, and even if I return 0, okay, I'll get an error. That display is already defined in car. Okay, now the reason compiler is giving error despite we haven't different return types is because it's using method signatures to resolve the method calls. Okay, and the method signature for both the methods will be same. Okay, so this is about method signature in Java. Okay, I wanted to take a moment to explain this particular concept to you guys, because going ahead we will be doing certain things, or we will be learning certain concepts wherein we need to understand what is method signature in Java. Okay, so in this particular lecture we covered what are method signatures in Java. We learned what does method signature consist of. Okay, and we also took a look at some of the scenarios in what happens if you have methods with similar name, if you have methods with different return types but same name. Okay, we get an error. So we took a look at some of the scenarios. Okay, and we also took a look at how compiler resolves method calls using method table. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you.
Hello guys, welcome back. So in this lecture we are going to discuss about inheritance. By the end of this lecture you will have a better understanding of what is inheritance in Java. We will also take a look at some of the keywords that are important, or some of the terminologies that are important in the world of inheritance. And we will also be doing an example program that will help us understand more on how we can implement inheritance. So let's get started. So to understand inheritance, I will like to take an example over here. Okay, so let's assume there are three cars. Okay, Ferrari, Tesla, and Audi. Okay, now these three cars are of the type car. Okay, correct. Like Ferrari is a type of car, Tesla is a type of car, and Audi is also a type of car. Okay, now this type of relationship between Ferrari and car, okay, is also known as is a relationship or parent child relationship or inheritance in the world of object oriented programming. Okay, so we can also say, so if we have to take a look at some other example like that of a mobile phone, so we can say iPhone is a type of a mobile, right? Samsung is a type of a mobile phone. Okay, so this relationship between the iPhone and a mobile phone is known as is a relationship or parent child relationship or inheritance. Okay, in object oriented programming. Okay, now the reason this is called as is a relationship or parent child relationship is because now over here Ferrari, if you look at Ferrari, is a kind of a car. Okay, is a type of a car. Okay, now car is a categorization of Ferrari, Tesla, and Audi at a broader level. Okay, at a higher level. Okay, and if we have to make some specific car, we have to drill down into the lower level, which is known as Ferrari, Tesla, and Audi. Okay, now this is an example of a scenario in real world. Okay, now if you have to represent this relationship between Ferrari, Tesla, Audi, and car, okay, we have to represent it in this way. So this is the syntax of representing inheritance in the world of Java. Okay, so we can define class over here. Okay, so class, parent class. Okay, so now in this particular relationship I would like to mention that car is also known as parent class. Okay, and Ferrari, Tesla, Audi are also known as child classes. Okay, so over here in syntax we have to mention, okay, class, parent class. We have to first define the parent class over here. Okay, we have to define corresponding methods and fields. So as per our example, okay, this particular example over here, okay, here we will define class car. Okay, we will define all the methods and fields within the class car. Okay, and then we will define three classes, okay, which is Ferrari, Tesla, and Audi, okay. So I'll just take Ferrari for now for the sake of this example, okay. So we'll create a Ferrari class Ferrari extends car, okay, and then we will define methods and field within Ferrari class, okay. Now, one point to be noted over here, that is a relationship or parent-child relationship or inheritance. Okay, these three are same. Okay, just different terminologies. Okay, so if you have to implement is a relationship in Java, you can do it using the extends keyword. Okay, so extends is the keyword that helps you implement this particular relationship that we are seeing on the screen. Okay, so this is a syntax. Okay, we will soon hop on to our IDE and we'll write a sample program that will help us understand even better. Okay, so this is how it will turn out to be. Okay, so we can say that class Ferrari extends car. Okay, class Tesla extends car, class Audi extends car. What this means is Ferrari, Tesla, and Audi are simply inheriting car class over here. Okay, so why would Ferrari, Tesla, and Audi want to inherit car class? Okay, now the reason for doing so is whichever class inherits this car class, okay, gets all the methods and fields, okay, defined in the car class. Okay, so if Ferrari extends car class, okay, all the methods that we have defined in car class and also fields, which means variables, etc., okay, all these will be accessible within the Ferrari class. So if you have one method in Ferrari and one method defined in car class, okay, with the help of the extends keyword, Ferrari will have two methods in it. One is from the Ferrari class and one is from the car class. Okay, so we'll soon demonstrate this with the help of the example on the IDE. So let me explain to you different terminologies that we use, that everyone uses in Java to call parent and child classes. Okay, so car class is also known as superclass, parent class, or base class. Okay, because this is the class that is getting extended by different classes. Okay, and Ferrari, Tesla, and Audi are also known as subclasses or child class or derived class. Okay, different people will use different terminologies in the world of object oriented programming. Some might call it superclass, some might call it base class, some might call it parent class. So it's important to know that three of them mean the same. Okay, so let's hop on to our coding editor and write a sample program that will help us understand inheritance even better. Okay, so we are on our coding editor. Now what we are going to do is we are going to define a parent class, okay, which has a variable and a method. Okay, then we are going to define a child class which has again a variable and a method. Okay, and we will be extending this child class with the parent class. Okay, so and then we will define a main class, okay, from where we can call a parent and child classes. Okay, so I have already created a sample project over here. Okay, and I'll go ahead and create our parent class. Okay, I'll call it car, like our example. Okay, and I'll define integer, public integer seats, okay, is equal to 4. Okay, I will also define a method over here. Okay, public void display. Okay, and we'll print in parent class. Okay, or we'll just print in parent class. Okay, and now what I'll do is I'll create one more class called as Ferrari. Okay, and I will just define one method over here. Okay, okay, which says similar.println in Ferrari, okay, and I will also extend this Ferrari with the class car, okay. Now I'll create one more class, okay, called as the main class, okay, in main, okay, and I'll define public static void main over here, okay. So we have created three classes. One is car class, okay, which has one variable and one method. We have one child class which has one method, okay, and then we have created a main class to call both these classes, okay. So we have so one point to be noted over here is car class has one variable and one method, okay, but Ferrari class has one variable and two methods, okay. Now the reason for this is we have only defined one method over here, okay. So you would say, hey, it has only one method, how come it has two methods and one variable as well? So since we are extending Ferrari class with the class car, okay, so Ferrari class by default will inherit all the properties and methods of the car class, okay, and which are only public in nature. So Ferrari class has two methods and one variable, okay. Now you might say, hey, how come Ferrari class has one variable and two methods? So the reason for this is since we are extending Ferrari with the class car, okay, so we are doing an inheritance over here, okay. Now whenever you do an inheritance, all the properties and methods in the parent class is by default available in the child class, okay. So whatever properties that we have defined over here, okay, which are public, so here we have a variable seats and a method called as display, okay. Now these both will be by default available to the class Ferrari, okay, because Ferrari is extending class car, okay, and hence we have one method which we have defined in Ferrari class, okay, and one method and one variable which we have defined in car class, both available to the Ferrari class, okay. So let me demonstrate this in the main class, okay. So first I will create the object of the car class is equal to new car, okay. I'll try to call c dot display, okay, and I'll try to run this program, okay. So this should ideally print parent class, okay. So there you see we are able to access this particular method over here, and I can also access seats over here, okay, because seats is also a part of the parent class, okay. But I'll just print in this particular line, okay, system.out.println, okay, and I'll just print in seats, okay. I'll try to run this program. So we are able to access seats as well, okay, with the car class object, okay. Now if I try to access c dot display Ferrari, okay, it will throw me an error, okay, because parent class object can't access child class methods and variables, okay. The reason for this is Ferrari class is extending car class, and car class is here is not extending Ferrari class, okay. So the properties and variables that we have defined in Ferrari class are not by default available to the car class, okay, because car class is not extending Ferrari, but Ferrari is extending car, okay. So this statement is invalid over here, okay. I'll just comment this out, okay. Now I'll create an object of Ferrari class, okay, Ferrari, okay. Now I'll try to call f dot display Ferrari, okay. I'll run this code, okay. Now obviously this code should work because display Ferrari is a part of Ferrari class, okay. And we see the output, okay. We see in Ferrari getting printed. Now, by the concept of inheritance, we said that all the objects, all the properties and methods that are defined in the parent class are by default available to the child class. Okay, so let's try and call display method here, which is defined in the car class from the Ferrari class object. Okay, so I'm just going to do f dot display. We see it in the suggestion over here. Okay, and I'll try and run this code. Okay, ideally this should run with the rules of inheritance, and there you see parent class getting printed. Okay, so what we learned over here is the methods and variables that are defined in the parent class are by default available to the child class, and you can call it using the child class object. Okay, I'll also try to call the seats variable over here, and you'll get an idea that you can access variables also. So this is the Ferrari class object, and seats is defined in car class, and I'll run this code. Okay, so ideally it should print 4 again, and there you see it prints 4. Okay, let's take a look at one more scenario. Okay, so I will create an object of car class over here. Okay, which is nothing but the parent class as per our code. Okay, so now this is the car class reference variable. Okay, now I won't assign the car class object to the car class reference variable, but instead I will assign this with the Ferrari class. Okay, so I will initialize this with the Ferrari class object. Okay, okay, so it's saying C is already defined in scope, so I'll make it CF. Okay, so what we have done over here is we have defined a car class reference variable. Okay, so this CF is nothing but the reference variable of the car class. Okay, and we have assigned it with the object of the Ferrari class, which is the child class of the car class. Okay, so we have assigned the reference variable of the parent class with the object of the child class. Okay, so this is perfectly valid in Java. Okay, you can assign a reference variable of a parent class and initialize it with the object of the child class. Okay, so I'll go ahead by writing cf dot seats. Okay, I'll just print in this line. Okay, you can definitely so I'll just write in over here cf. Okay, and this is also a valid statement. Okay, since we are accessing seats variable with the parent class object. Okay, and now I'll try to call cf dot display. Okay, so this is also a valid statement because we are calling the function in the parent class using the reference variable of the parent class. So parent class over here is car. So a function is defined in the parent class, and we are trying to call it using the reference variable or the object of the parent class. Okay, so let me execute and show this to you. Okay, so this particular code perfectly works. Okay, it's perfectly fine. Now I'll try to call the display Ferrari method, which we have defined in the Ferrari class, which is nothing but the child class. Okay, so I'll write cf dot display Ferrari method. Okay, now compiler is going to throw an error over here. It will say that I cannot access display Ferrari. Okay, because we are using display Ferrari is defined in the child class, and we are trying to access it using the reference variable of the parent class. Okay, so this is the reason why we can't access display Ferrari method. Okay, okay, so I'll comment this particular line over here. Okay, now what we did over here is we assigned the child class object to the parent class reference variable. Okay, so now what I'll try to do is I'll try to assign a child class reference with the parent class object. So our child class is Ferrari. Okay, I'll create CFC. Okay, and I'll try to assign it with the parent class. Okay, now we are going to get a error over here that This is incompatible types. Okay, so you cannot assign the object of the parent class to the child class reference variable. Okay, this is completely invalid, so compiler will throw an error on this. Okay, so let's take a look at some of the facts that we can derive with the help of this example. Okay, so I'll hop on to my presentation. Okay, and the first fact that we can talk about is parent class reference can be used to hold a child object, but child class reference cannot be used to hold a parent object. Okay, so here we created a parent class reference. So we are already aware that object creation is a two-step process. So you can define like car c1. Okay, okay, and then you can create the object, actual object over here, like new car. Okay, and c1 is nothing but the reference variable, and this second step is nothing but the object initialization. Okay, and we combined these two steps in one step over here. Okay, to write it in a single line of code. Okay, which is something like this. Okay, so c1 is nothing but the reference variable over here. Okay, so I'll just erase this. So as per this particular fact, parent reference can be used to hold child object, but child reference cannot be used to hold parent object. So we saw this in the example that parent reference can be used to hold child object. So CF is the parent reference of the car class, which we are using to hold a child object. But we tried to use parent child reference to hold the parent class object, but compiler thrown an error. Okay, so this is one of the facts that you're supposed to remember. Okay, so second fact is parent reference can be used to hold child object. Okay, this is also known as polymorphism, which we will discuss. Okay, but using the child reference, we can't call child specific class method, but we can call the methods present in the parent class. So we could so by using this parent reference, okay, which has the initialization of the child object. Okay, we could call the method in the car class, but not the method in the child class. Okay, so this is something that we saw already. Okay, methods and variables in parent class are by default available to the child class, and hence we can call both the methods and variables in parent and child class on child reference. Okay, so we tried doing this as well. Okay, so we saw that how we can access the parent class methods by using the child class object. So display was a method in the parent class, which is nothing but the car class. Okay, and we were able to call it by using the child reference over here. Okay, so this was perfectly valid. The fourth fact is methods and variable in child class are by default not available to the parent. Okay, hence we can't call child specific methods and variables in parent and child class on parent reference. So we already saw this particular fact wherein we tried calling the child specific methods. Okay, by using the parent class reference over here, but we got an error. Okay, so the fifth fact is that if we do not extend any class, then that particular class is the direct child of the object class. Okay, so whenever, so what this means is object class is the parent of every class in Java. Okay, so if we have created a class and if we don't have a parent to that particular class in our code, okay, by default compiler will make sure that it's the direct child of the object class. Okay, so over here child class is not inherited by any class. Okay, so it does not extend any class, but in background, okay, compiler makes sure that it is a child class of the object class, which is of the Java library. Okay, so object class is nothing but the part of the Java library, okay, which is the parent of each and every class in Java. Okay, but Ferrari class is not the direct child of the object class, since we are extending car over here. Okay, so these are some of the facts that you're supposed to keep in mind that are very important from the interview perspective as well. So if you are applying for a job in Java, interviewer might ask you these questions to check if you are well versed with the concept of inheritance in Java. Okay. So in this lecture, we covered a lot. We discussed inheritance, or is a relationship, or a parent-child relationship. Okay. You can refer inheritance using any of the three terminologies. Okay. We also discussed the syntax on how you can implement inheritance in Java. We understood what is inheritance in Java. We also wrote a sample program which helped us understand the implementation of inheritance, and we also derived some of the facts from that particular example. Okay, I hope you guys enjoyed this particular class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to discuss the need for inheritance. So we are going to talk about why you should use inheritance, or why this concept of inheritance exists in Java. Okay, this will help us understand the importance. Okay, and it will also give you a clarity on why this concept exists. Okay, so let's get started. To demonstrate the need of inheritance, I am going to give you an example of a banking module. Okay, so imagine you are a software developer at a bank. Okay, and you have a team. Okay, and you're building a banking module. Okay, which is related to accounts. Okay, so in order to build that module without inheritance, so we'll see how we will build it without inheritance, and we'll also see how that can be built with inheritance, and how it simplifies everything. Okay, so without inheritance, you will have different kinds of accounts in the bank. Okay, which is savings accounts, current account, student account. Okay, and to have the functionality of saving account in your module, you need 500 methods. Similarly for current account, and similarly for student account. Okay, so in total you have to write 1500 methods. Okay, and this makes the code really lengthy. Okay, so 1500 methods you have in total in your project. Now let's take a look on how you will build the same module. Okay, with inheritance. Okay, so with inheritance, what you can do is, savings, current, and student are nothing but types of account. So you can define a parent class called account. Okay, which has all the common methods across the accounts in the bank. Okay, and then you can create specific account. Okay, which is nothing but student account, current account, and savings account, and inherit the account class as the parent. Okay, so let me demonstrate this in a more clear way. Okay, so every account needs to validate a user. Every account needs to calculate the interest. Okay, every account needs to deposit money, and every account also has a function to withdraw money. Okay, so these functionalities are common across the accounts. Okay, so what we can do is, we can take the common methods or the common functionalities all of all the accounts. Okay, and create a parent class called account. Okay, which is a general class which has all these common functions. Okay, and then we can create specific accounts, which means student account. It's a specific type of account, and inherit the account class. Okay, now what will happen is, when you inherit the account class with the student class, all the functions like deposit, withdraw, calculate interest, validate user will be by default available to the student account. Okay, and you can create the object of student account and perform all those operations. Okay, now this also makes sure that you are not rewriting the code again and again. Okay, so in this particular method over here, you have to write withdraw function over here, you have to write withdraw function in current account, you have to write withdraw function in student account. So all three places you have to write withdraw function. Okay, but over here you have to write withdraw function once in account class. Okay, and all the three classes can inherit the account class, and by default they have the access to withdraw function. Okay, so if a user wants to withdraw from the student account, we call withdraw function, which is available in account class. Okay, similarly for current account, and similarly for savings account. Okay, now this promotes reusability a lot. Okay, so this is one of the important features of inheritance and why it exists. So reusing the common code or common functionality, okay, which is also known as code reusability in object oriented world, okay. So the main feature of inheritance is that it promotes reusability and it simplifies the code a lot, okay. So in this case, the withdraw function is written once in the account class and it's being reused by all the three classes, okay. And in future, if you add multiple accounts, okay, so let's say if I add one more kind of account called if a bank adds one more type of accounts in future called as senior citizen account, for example. So in this case, you have to create senior citizen account again, the fourth account, and you have to define all the methods again, like withdraw, deposit, validate user, everything. Now in this particular method, you can just create the senior citizen account class over here, and you can just extend it by the account class, which has all the common methods. So since the account class has all the common methods, by default they'll be available in senior citizen account, okay. So you don't have to rewrite them, and it promotes reusability and it also simplifies your code. Now if you have to do any changes in future in the withdraw function or in the withdraw method, so let's say earlier our bank was not validating the user before withdrawing, for example, and now we are also validating them. So in this particular method without inheritance, you have to add this change to the code in all the three classes, okay. But over here you have to just make it once in the parent class and it's automatically available in the child classes, okay. So it also promotes maintainability of the code and it also makes it easy for the future development and enhancement, okay. So this is how inheritance becomes really useful in the programming world, okay. And also I would like to mention that you are writing 1500 methods over here in total, but in this particular method you are just writing 700 methods. So it also reduces the code size or the code base by a lot, okay, and it's very easier to maintain as well. So to use inheritance effectively in your project, I'm going to give you some tips, okay. So if you are writing multiple classes, okay, like for the same type which have some same type, okay, now how are you supposed to decide whether which methods you're supposed to define in the parent class and which method you should define in the child class, okay. So for this, you should look at all the classes, okay. So for example, here you have all the classes like student account, current account, saving account, okay. Now what is common in all these classes? So all these classes have deposit function as the common function, withdraw function as the common function, okay, validate user as the common function. So what you can do is you can collect all these common functions or methods and variables also, and you can create a parent class and you can put all this common stuff in that particular parent class, okay, which is applicable for all three, okay. And you can and the child classes can only have child specific method, okay. So for example, for student account you have to collect or you have to validate the college name. So you don't need to put a validate college name method in the account class, but you can have validate college name method only in student account, because validate college name is not valid or not applicable for current, savings and any other accounts you might add in future. So that's the reason you will have that particular method which is just specific to student account in the student account class, okay. So that's how you define it, okay. So here I have just written an example of the common method that is applicable for all the three classes, okay, which is calculate interest. So what you can do is you have to calculate interest for all the type of accounts. So what you can do is you can move this calculate interest method to the parent class, okay. And some child specific method, like for example restrict check facility. So for example, if your bank doesn't provide check facility to the student account, okay, so you can have restrict check facility method in the student account, but it's applicable to current account and savings account, so you don't need to move this method to the parent class. So this is how you decide on which method you should include in the parent class and which method you should have in the child class, okay. So I hope you guys understood what is the need of inheritance in Java and why such concept exists. Okay, I hope this gives you a clarity on why it's important to learn inheritance and why it's important to use inheritance in your real world software projects. I hope you guys enjoyed this class and found it valuable. If you have any questions, you can ask me in Q&A section. I will be happy to help you. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, I'm going to talk a little bit about some of the examples of inheritance or is a relationship in Java, okay, that already exist. So the first example is the exception hierarchy, okay. So this is how the exception hierarchy is implemented in Java, okay. So we have at the top object class, then we have throwable, then we have two subclasses called as exception and error, and which in turn have all these type of child classes as the exception class, okay. And in error we have these child classes, okay. So this is how exception hierarchy is implemented in Java, okay. And you can see from the diagram over here that it completely has inheritance concept in it, okay. We have used inheritance over here extensively, okay. So what this means is if you are trying to access if you're trying to use class cast exception class, okay, you can access the methods that are defined in exception class using the object of class cast exception, okay. So all the common methods and all the common variables that are needed for all the exception class will exist in the parent exception class, okay. So this is an example of inheritance, okay. Another example that I have to talk about is the entire Java library or the Java API is implemented using inheritance. So at the root in Java library, we have the object class, okay, and over here in this diagram, it's extending the throwable class, okay. Throwable class is extending the object class, and I haven't shown the other classes because this is diagram is specific to exception hierarchy. But over here we have various classes like string builder, and many other classes extend the object class directly or indirectly, okay. So the entire Java library is implemented using the concept of inheritance, okay. So that's about this class, guys. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to talk a little bit about what are the different types of inheritance in Java or in object-oriented programming, okay? So by the end of this lecture, you will be having a clear understanding of what are different types of inheritance and what does each type mean, okay? So let's get started. So the following are the types of inheritance in Java, okay? First one is single inheritance, hierarchical inheritance, multi-level inheritance, multiple inheritance, and hybrid inheritance. So we have 5 types, okay? Let's take a look at each one of them and what each one means. So the first one is single inheritance. So single inheritance looks something like this, okay? So if one class extends another class, it is known as single inheritance. So your class B is extending class A, and class A is the parent class of class B, okay? So this is an example of single inheritance in Java, okay? Let's take a look at hierarchical inheritance. So hierarchical inheritance is nothing but the relation that looks something like this. So your class B is extending A and class C is also extending A. So A is the parent class of two classes, okay? And this is nothing but an example of hierarchical inheritance in Java, okay? Next is multi-level inheritance. So multi-level inheritance looks something like this. So in this particular relationship, C class extends B and B class in turn extends A. So A is the parent of B and B is the parent of C. Okay, so this is nothing but the example of multi-level inheritance in Java and in object-oriented programming. Okay, Third one, the next one, I'm sorry, is multiple inheritance. So multiple inheritance looks something like this. So class A is extended by class C, and class B is also extended by class C. So class C inherits two classes. Okay. So this type of inheritance is not supported in Java. Okay, but we'll be discussing about this. Okay, in our later lectures. Okay. Next type is hybrid inheritance. So hybrid inheritance looks something like this. So B and C, both classes extend A, and D class extends B and C. Okay. So it's a combination of multiple and hierarchical inheritance. Okay. This is nothing but known as hybrid inheritance. Okay. So in this lecture, we understood what is single inheritance, what is multiple inheritance, what is multi-level inheritance, what is hierarchical inheritance, and what is hybrid inheritance. Okay. So there are 5 types of inheritance in object-oriented programming with Java. So I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to understand and implement an example of single inheritance in Java. So let's get started, guys. So we already know that single inheritance is this type of relationship wherein one class extends another class. Okay, so here class B extends class A. Okay, so we are going to hop on to our IDE. Okay, and we need two classes to implement single inheritance. Okay, so what I'm going to do is I'm going to first create the parent class, which is class A. Okay, and I will define a method over here. Okay, public void display. Okay, or I'll define a method A. Okay, and I'll just print in A method A. Okay, now what I'm going to do is I'm going to create one more class which will be the child class of this particular class, which is B as per our example. Okay, and I'm just going to extend B with A. Okay, and I'm again going to define a method called uh, method B. Okay, so here we have method A, here we have method B. Okay, and I'm just going to print in system.out.println. Okay, method B. Okay, I'm going to save the project, and I'm going to create a main class now over here. Okay, so single inheritance main. Okay, and I'm just going to define public static void main. Okay, so to write public static void main, you can just type in psvm, and IntelliJ is smart enough to type the entire line for you. Okay, now here A has one method. Okay, but B has two methods because B is extending A. So B also has the method A and method B. Okay, so I'm going to create an object of B class. PB is equal to new B. Okay, and I'm going to call in B dot method A and B dot method B. Okay, I'm going to save the project and I'm going to run this particular file over here. Okay, so there we see the output. We see method A getting printed and method B getting printed. So you can call both the methods in class B and class A using the class B object. Okay, so this is nothing but what we did is we implemented a single inheritance. Okay, which is this particular concept over here. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to take a look on how you can implement hierarchical inheritance in object-oriented programming using Java. Okay, so on my screen, you can see how hierarchical inheritance is implemented. Okay, we have class B and class C which extend class A. Okay, So both these classes extend the same class. Okay, so we are going to implement this particular relationship over here. Okay, and I'll hop on to our ID, and I've already created a sample project over here called hierarchical inheritance. Okay, what I'm going to do is I'm going to create a class called class A. Okay, now this class is nothing but our parent class as per the example. So class A. Okay, and then I'm going to define a method. Okay, so it's public void method A. Okay, and it prints system.out.println. Okay, method A. Okay, now what I'm going to do is I'm going to create one more class called B. Okay, now B class extends A as per our example. Okay, now I'm also going to define a method over here which says public void method B. Okay, and this also prints in. So this is a shortcut to print in system.out.println in case you don't know. So system.out.println. Okay, and method P. Okay, and I'm going to create a third class over here which is class C. Okay, so it extends class A. Okay, and I'm going to define the method public void method C. Okay, system.out.println method C. Okay, so we have three classes B and C extend A, and A is the parent class of both the class. Okay, and I'll create a third class over here which is main class. Okay, and we'll type in public static void main. Okay, now I'll create the object of B class first. Okay, B is equal to new B. Okay, now you can call B dot method B because method B belongs to B class. Okay, you can also call B dot method A. Okay, because method A belongs to class A. So A class has one method, B class has two methods like method A and method B. C class also has two methods, method A and method C. Okay, so you can call two methods from B class using the B class object, method B and method A. Okay, but a point to be noted over here is you can't call method C over here because it belongs to C class. So it belongs to C class over here, which you can't access from class B. Okay, so I'll comment this line. Okay, I will just run this code and we'll see the output over here, what it looks like. Okay, so there we see the output. We see method B and method A getting printed. Okay, so what I'm going to do now is I'm going to create the object of method C, of object C, of class C. I'm sorry, and I'll call in C dot method C and C dot method A. Okay, but remember that you can't call C dot method B over here again for the same reason that methods defined in class B cannot be accessed from class C because they both don't have any relationship. So anything you defined in B cannot be accessed from class C because there is no relationship between B and C. But yes, you can access the methods or members declared from in class A, from class B and class C. Okay, so I'll run this code. This should work perfectly fine. Okay, it should print method C and method A. So there we see the output. We see method C and method A getting printed on the console. Okay, so this is what is hierarchical inheritance and how you can implement it in Java. In this lecture, we implemented hierarchical relationship, okay, hierarchical inheritance by defining three classes A, B, and C, wherein B extended A and C also extended A, okay, and we tried calling methods from those classes, okay, using the corresponding objects.
So I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to talk about multi-level inheritance in Java. And we are also going to implement this multi-level inheritance in our IDE. Okay. So this is what multi-level inheritance looks like. Okay. So we have class C, which extends class B, and class B, which extends class A. So A is the parent of class B, and C class indirectly inherits the property of class A. So from C class you can call methods and variables, okay, of the A class. Okay, so let me show you this with an example. So I have IntelliJ IDEA open in front of me, and I have already created a sample project called multi-level inheritance. I'll go ahead and create a class called A. Okay, and I'll define a method saying public void method A. Method A. So this is what it prints, method A, and this is class A. We'll create one more class. Okay, class B. Okay, and this class also has the same method, public void method B. Okay, and this also prints method B. Okay, and we'll create another class over here. Okay, class C. Okay, this class also has a method called method C, and it prints method C. Okay, now as per the diagram, class C should extend class B. So I'll extend class B over here. Okay, and class B should extend class A. Okay, so I'll go to class B and it extends class A. Okay, so B extends A. Okay, and C extends B. Okay, now I'll create one more class called main. Okay, main class. Okay, and I'll define public static void main. So I'll create the object of A class first. Okay, so using the object of A class, you can call method A. Okay, so this method is already defined in class A. Okay, but using the object of class A, you cannot call method B, and you cannot call method C. Okay, the compiler will throw an error because they are the methods defined in class B and C, which are the child classes of class A. Okay, so this is good, but I'll create the object of class B now. Okay, is equal to new B. Okay, I'll access method A from here, and I can also access method B from here. Okay, so from B class you can access methods in class A, which is the parent of class B, and you can also access the method B, or the method defined in class B. Okay, but you cannot access the methods that are defined in class C. Okay, so this will be an error. Compiler will throw an error on this because this is defined in the child class of class B. Okay, now let me create the object of class C and show you. Okay, so you can call method C. Okay, you can call method B. Okay, and you can also call method A over here. Okay, so you can make a note over here that you can call the methods defined in class C. Okay, obviously because it's the object of the same class C. You can also call the object of method B. Okay, which is the parent class of class C. Okay, you can also call the methods defined in class A because class C is indirectly inheriting the properties of class A. Okay, so since B class is extending A and we are extending
in C class extending B. Okay, so A class is indirectly inherited in C. Okay, so A has one method, B has two method, and C has three methods. So C has access to all the properties of class A and B. Okay, so this is what is multi-level inheritance. I'll just run this code and I'll show you the output. Okay, ideally everything should run perfectly fine. Okay, so there you see the output. You can see everything getting printed as it is. Okay, so this is how you can implement a multi-level inheritance in Java, okay, or in object-oriented programming. Okay, it's a very important concept. Okay, so wherein we have indirectly inherited the class A. Okay, so in Java, every class is the child class of object class. Okay, whether it's directly or indirectly. Okay, so if a class doesn't extend anything or doesn't inherit any other class, okay, it's the direct child class of the object class. Okay, but if a class extends any one class at least, okay, then that class is the indirect child of object class. Okay, so let me show this to you with the help of an example. Okay, so here in our example, A is not extending anything, but B is extending one class and C is also extending one class. Okay, so from A, from using the object of A, you can call equals method. Okay, now what is equals method? So equal method, you can just press command and you can hover the mouse. Okay, so command on Mac and control on Windows. Okay, so just hold it and just hover the mouse on this, so you will see it turns into an hyperlink over here. Okay, and you tap on it. So equals method, you can see in this file, we opened the object.java class, which is nothing but the object class, and equal method is defined in object class. Okay, so this is the part of the Java library. Okay, so you saw that we can access equals method, okay, using the object of class A. Okay, which means that class A is inheriting object class. Okay, and it is inheriting this directly and not indirectly. Okay, now what does direct inheritance means? Okay, so B class is extending class A directly. Okay, B class is extending class A directly, but C class is extending class A indirectly. Okay, now why is C class extending class A indirectly? How come that happen? Because A is getting extended by B. I'm sorry, B is extending A. Okay, and C is in turn extending B. So in that case, class A is getting indirectly inherited to C. Okay, so this is indirect and indirect relationship. Okay, so A class is directly inheriting the object class. Okay, and you saw this over here. Okay, we can call the equals method, but you can also call the equals method from B class. Okay, you can see over here. Okay, and this is the object class only. Okay, so what happens is A class is extending object class and B class is extending A class. So in that case, indirectly, B class can access the methods and properties of object class. Okay, so that's one point to be noted. Okay, so every class in Java is the child of object class. Okay, please remember this. This is also an interview question which my students have been repeatedly asked. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to take a look at what has a relationship in object-oriented programming. By the end of this lecture, you will have a better understanding of has a relationship in Java. You will also understand what is composition, aggregation. These are some of the terminologies related to has a relationship in Java. So let's get started, guys. So to discuss has a relationship, we will have to discuss the example of car and an engine. Okay. So what is the relationship between a car and an engine? So car has an engine. Okay, you cannot say car is an engine or engine is a car. Okay, there is no is a kind of relationship, but the relationship is of has a kind. Okay, so in is a relationship we saw that Ferrari, Tesla, Audi is a type of car. Okay, Ferrari is a type of car, Tesla is a type of car, Audi is a type of car. Okay, so we never said that Ferrari has a car or car has a Ferrari. Okay, so the relationship between Ferrari and car was of is a type. Okay, but the relationship between car and engine is of has a type. So in car has an engine. Okay, car is not a type of engine or engine is not a type of car. Okay, so this sort of relationship is known as has a relationship. Okay, and this example or this diagram perfectly represents it. Okay, so here you can see that engine is within the car. Okay, but over here Ferrari, Tesla and Audi are the type of cars. Okay, so this is has a relationship. Okay, now there is no particular keyword to implement has a relationship. Okay, we saw how we can implement is a relationship using extends keyword, but to implement has a relationship we don't have any keyword, but this is how it will be implemented. Okay, so we'll first define the class engine. Okay, and then in class car we create the object of engine type. Okay, and this relationship is then known as has a relationship. Okay, so has a relationship is also known as composition or aggregation. Okay, but there is a slight difference between these two terminologies, composition and aggregation. Let me explain that to you. Okay, so let's take an example of a university which has several departments. Okay, so university has department 1, for example, department 2, department 3 and department 4. This university is known as container object. Okay, in the object oriented world, and department is known as contained object. Okay, because university acts as a container which has departments. Okay, and department is within the university, hence it is known as contained object. Okay, now department cannot exist without university. Okay, so if university is destroyed or shut down, departments will automatically be shut down. Okay, so university and department are very strongly associated. Okay, you can say like without university department cannot exist. Okay, and this type of strong association, okay, is known as composition. Okay, so to define composition is when there is a possibility that a contained object could not exist without the existence of container object. Okay, that particular relationship or that particular association is known as composition. Okay, now let's understand what is aggregation and how it differs from the composition. Okay, so we'll take the same example of university, but this time we'll take lecture in picture. Okay, so university has several lecturers. Okay, now there is a possibility of existence of lecturers when university is destroyed. Okay, so lecturer can go elsewhere and take lectures. Okay, so university existing or shutting down, it doesn't matter to them. Okay, if they are teaching at one university today and if that shuts down, they can go to some other university and teach. Okay, but this was not the case of the university and department. Okay, for department to exist, university had to exist. Okay, so over here that is not the case. So if university is destroyed, lecturer can go to some other university and give lectures. Okay, so we can say from this example that lecturer and university are weakly associated. Okay, and this type of weak association is known as aggregation. Okay, so in composition, the container objects and contained objects are strongly associated, but in aggregation, container object and contained objects are not strongly associated, but they are weakly associated.
and this is the difference between composition and aggregation. So this is also a very popular interview question which has been asked repeatedly in interviews. So make sure you memorize this. The difference between aggregation and composition is, in composition, container objects and contained objects are strongly associated, but in aggregation, container objects and contained objects are weakly associated. In this lecture, we understood what is has a relationship in object-oriented world. We also took a look at some of the terminologies associated with has a relationship, which is nothing but composition and aggregation. And we also learned what is the difference between composition and aggregation. So I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you.
Hey guys, welcome to this class. So in this lecture, we are going to talk about another OOPS concept, which is polymorphism. So let's get started. So polymorphism is a Greek word wherein poly means many and morphism means behavior. So it means many behavior. So what is polymorphism? So polymorphism is nothing but an ability of an object to take more than one forms or behavior. Now what does it mean? So let's take an example of a person, which is me. Okay, so I have different behavior in front of camera, at home, with friends, when I'm watching movies. So I exhibit different behavior at different places based on the conditions. Okay, so this is nothing but me exhibiting polymorphism. So there are two types of polymorphism. One is compile time or static binding or early binding, and another one is runtime polymorphism or dynamic binding or late binding. Okay, so an example of compile time polymorphism is overloading. We'll be discussing more about what is overloading and what are different types of overloading, and we will also be writing some programs to demonstrate overloading in our next lecture. Okay, an example of runtime polymorphism is overriding. So we'll also be discussing overriding, and we'll also be creating some programs, sample programs to exhibit this behavior in our following lecture. So that's about the conceptual overview of polymorphism, guys. See you in the next class. Thank you.
Hello guys, welcome back. So in this lecture, we are going to take a look at method overloading in Java. So by the end of this lecture, you will have a better understanding of what is method overloading in Java. And we will also take a look at one of the sample example that illustrates the concept of method overloading. Also, we will understand how method overloading is beneficial and what are the advantages of having method overloading in Java. So let's get started, guys. So what is method overloading? So whenever you have two or more methods having same name but different argument types, such methods are known as overloaded methods, and this concept of having multiple methods with same name but different argument types is known as method overloading. Okay, so what I mean by this over here is if you have a class A and let's say you have a method m1 and again you define method m1, but the first method m1 does not have any argument, and the second definition of method m1 has one argument. Okay, so here there are two methods with the same name but different argument types. Okay, so one doesn't have any argument but the second method has the argument. So this is nothing but the method overloading concept. Okay, and such methods like these two methods are known as overloaded methods. Okay, let's take a look on how method overloading makes life easier. Okay, so in C programming, okay, if you have to find absolute of an integer, you call absolute function, okay, with the integer parameter. Okay, so this function is abs and in bracket you have integer I. Okay, now if you want to find absolute of a long number, you have to call a different method called labs. Okay, and in bracket you have to pass the long variable. Okay, now if you have to do the same for float, there is a third function with float as the parameter. So if you have to do the same with the float value, okay, there is another function with float as the parameter. Okay, so there are three different methods, okay, to perform the exact same operations, okay, but for different data types. So for integer there is one function, for long you have one function, and for float you have one function. Okay, so C programming is not an object oriented programming, and it doesn't support method overloading. Okay, and that is the reason why we have different methods for performing same operations on different data types. Okay, now let's take a look at Java programming. Okay, so the same example, if you have to do in Java, okay, you have only one method. Okay, like, so in reality you have three methods, okay, but the method name is same. Okay, so the method name is abs. Okay, and now to this method, if you pass integer value, okay, it will perform the absolute for this particular value. Okay, if you pass long, it will perform the absolute. If you pass float, it will return the absolute. Okay, so this makes life much more easier because you don't have to remember multiple method names over here. Okay, but you have to just remember one method name and you can pass different values, okay, as per your requirement. Okay, so this improves the code readability and also makes the programmer's life easier. So let's now hop on to our IDE or coding editor, and let's write a sample program to illustrate method overloading. Okay, so I have my coding editor already open, okay, and I have already created a project called method overloading over here, okay, and also it has a class called method overloading.java. Okay, now what I'm going to do is I'm going to write in the class over here. Okay, so public class method overloading. Okay, and I'm going to define two methods, okay, with the same name but different argument types. Okay, so public void, okay, method 1. Okay, so this one has no argument. Okay, so I'll just type in over here no arguments. Okay, now I'm going to just copy this code. Okay, and I'm going to write a second method. Okay, so here compiler is going to throw an error that method 1 is already defined. Okay, but if you pass a argument integer I, okay, it says integer argument. Okay, the error goes away. Okay, the moment you pass the integer argument. Okay, and we are printing integer argument over here. Okay, I can just print the value of integer as well if I want. Okay, so integer I. Okay, so this is nothing but the example of method overloading over here on our screen, okay, wherein we have method 1 with no arguments and method 1 with integer argument. Okay, so method 1 is known as overloaded methods. Okay, and this particular concept is known as method overloading. Okay, so let's now write a main function and let's try to call these methods over here that we just defined. Okay, so method overloading is equal to new. First I'll create the object of this particular class. Okay, and then now I'm going to write in method overloading. Okay, dot m1. Okay, method m1, and then I'm going to write method overloading dot method 1 with a integer parameter. I'm just going to pass in 10. Okay, now I'll try running this program and we'll see the output. Okay, so the code got executed and we have the output. Okay, and the output is, it says no argument first. Okay, and then it says the integer argument. Okay, with 10 as the value. Okay, so basically what happened exactly is when we compiled the program. Okay, so first we defined these two methods, okay, with different arguments but same name. Okay, and we defined the main method and we called both this method that were defined, method 1 and method 1 with integer argument. Now when the program got compiled, okay, During compile time, the compiler linked this particular method call to this particular method, okay, and it also linked this particular method call with this particular method over here, okay. So this linking of which method to call when we actually execute the program is done by the compiler during the compile time, okay, and hence this particular concept of method overloading is also known as early binding or compile time polymorphism. So early binding because the binding of method call to the actual method is done by the compiler during compile time, okay, and compile time polymorphism because during compile time this particular linkage is done, okay. So this particular concept is also known as compile time polymorphism or early binding, okay. And this is a very good example of polymorphism in Java, wherein one method is exhibiting different behaviors over here, okay. So we have defined only one method called method one, okay, and this method has multiple forms, okay. So this method behaves differently when you don't pass any argument, and the same method will behave differently when you pass integer as the argument, okay. So this is a very good example of compile time polymorphism, and this is one of the important concepts in object oriented programming, okay. So let's hop on to our presentation, okay, and let's go a little bit further, okay. So there are different ways of overloading methods in Java, okay. So the first way is by number of parameters, okay. The second way is by the data types of the parameters, okay, and third one is by the order of the parameters, okay. So now what each one means, okay. So let's take a look at by number of parameters, okay. So what does overloading by number of parameters mean, okay. So this is, so here we didn't pass any argument, okay, we didn't have any parameter, okay, but here we had one parameter, okay. So this is nothing but an example of overloading by number of parameters, okay. So here we don't have any parameter, and here we have one parameter, okay. We can also make one more method, okay, with the same name and having two integer, okay. So basically I'll write in two integer arguments, okay. So basically this is nothing but overloading by number of parameters, okay. So your method name is same, but the number of arguments are different, okay. So here we have integer I, and here we have integer I and integer j. So clearly the number of parameters differs, okay, by keeping the method name same. The second way is by modifying the data types of parameters, okay. And now over here what I can do is we have a method definition with one integer as parameter, okay. So what I'll do is I'll replicate it and just change the data type, okay. So I'll just change it to float, okay. So now these two examples, okay, of the method with the integer data type and the method with the float data type are nothing but overloading by data types, okay. So here this is the example of the second way over here, okay. So here we just changed the data type, but we didn't change the number of arguments, okay, as in our first case, okay. Now the third one says by the order of parameters, okay. So method overloading can be done by changing the order of parameters, okay. So let's try and make that happen, okay. So here I have float I, okay. I will put in integer I, okay, not integer I, integer j, okay. Now here the order of parameter is integer j and float I, okay. Now what I can do is I can replicate the same method over here, and I can interchange the data type, okay. So I can make the float as first order and integer as the second order, okay. And now this is nothing but what we have done is the number of parameters is same, okay. The data type of the parameter is same, okay, but the order of the parameter is different, and this is
also a way to overload methods. Okay, so number of parameters are same, the data types of parameters are same, but the order of the parameters are different. Okay, and this is nothing but a way to overload a method in Java. So number of parameters are same, the data type of the parameters are also same, but the order of the parameters are different. So here we have integer float, but here we have float and integer. So this is nothing but a way to overload methods in Java. Okay, so let's now take a look at some of the advantages of method overloading in object oriented programming. Okay, so the first advantage is overloading in Java gives you the ability as a programmer to create multiple methods of the same name but with the different parameter. Okay, and this is indeed a powerful thing for you as a software engineer. Okay, the second advantage is it helps you maintain the cleanliness of the code. Okay, like we took a look at the example of finding an absolute value of a variable in C programming versus finding an absolute value of a variable in Java programming. Okay, we saw that we had to call different method names for doing the same function but with a different data type. Okay, so it indeed helps us maintain the cleanliness of the code. Okay, it increases the readability of the program. Okay, so here now you are calling method 1, okay, multiple times but with the different types of argument. Okay, so the programmer who is reading your code, okay, like if another software engineer is reading your code, okay, it will be very easy for him to understand that you are doing the same operation, okay, but for different variables. Okay, and it thus makes understanding really easy. The fourth advantage is overloaded methods gives programmer the flexibility to call a similar method for different types of data. Okay, so these are the four advantages of method overloading in Java. Okay, method overloading is a very powerful concept in Java, and it is really important interview question as well. Okay, my students have been repeatedly asked these questions in interviews. Okay, so let's summarize this lecture, guys. So in this lecture we understood what is method overloading in Java. We understood what are the advantages of method overloading in Java. We also wrote a sample program which gave us the clarity of this concept. Okay, and we also understood what are different ways to overload methods in Java. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to talk a little bit about what are the different rules of method overloading in Java. So by the end of this lecture, you will have a better understanding of what are the things that you are supposed to keep in mind before using this concept called method overloading in Java. So let's get started. So the first rule says that method can be overloaded by changing the signature of the methods. Okay. Second rule says the name of the method should be same for all the overloaded methods. Okay. The third rule says the return type of method is not the part of method signature. So just changing the return type will not overload the method in Java. Okay. So we already know this that the return type is never the part of the method signature. Okay. So two methods can only be overloaded when they have the same name but different parameters. Okay. Now return type doesn't come into consideration over here because return type is not the part of the method signature. Okay. So these are the three rules. Now the next rule says that Java performs an automatic promotion when it can't find a matching method. Okay. Now what does that mean? Okay, so whenever you are trying to call an overloaded method, okay, and let's say whatever parameter you have passed, for that particular parameter Java is not able to find a perfect match. Now in that particular case Java will perform an automatic promotion. Now what does this automatic promotion look like? Okay, so this is one of the type of the automatic promotion that can be performed by Java when it doesn't find a valid match. So this says that a character, if you have passed a character as a parameter, okay, but Java is not able to find the perfect match, so it can promote this character to integer, long, float, double, and so on till the time it finds the perfect match. So for example, if you pass a character and there's no perfect match, but there is a match for long, okay, so what the compiler will do is it will convert this char to int, okay, and then it will check for the match. But if you don't find a match for integer also, then it will convert to long, okay. Now long is where you find the match, suppose, then the compiler will execute this particular method with long as the parameter, okay. So let me show this to you to make it more clear with the help of an example, okay. So we will hop on to our IDE, okay. So I have this IDE open over here. I have already created a sample project called method overloading rules, and under the src folder I'm going to create a Java class which says automatic promotion, okay, rule. I'm going to press enter. Now over here I'm going to define a public static void main method, okay, and over here I'm going to define two methods, okay, which will help us demonstrate this particular rule over here and understand it even better. So I'm going to create public void m1, okay, and I'm going to print in system.out.println, okay. Now this particular method accepts integer as a parameter, okay, and I'm going to type in integer argument public var m1, okay. I'm going to type in float f, okay, system.out.println says float argument, okay. So we have created one class which has two methods which are overloaded, method m1 and again method m1, which accepts the float parameter and integer parameter respectively, and they both have a line which just prints that this is the integer argument method and this is the float argument method, okay. Now what I'm going to do is I'm going to create an object of this particular class over here, okay, and I'm just trying to call this method, okay. So if I call this particular method over here, let's say m1, okay, and I pass 10, the one with the integer argument is going to get called, obviously, okay. And if I call m1, okay, with the float argument, okay, 10f, then obviously the one with the float argument is going to get called. So let's check this scenario, okay. So there I see the output, okay, so integer argument and float argument, okay, getting printed, okay. So since I passed float parameter, it called the float version of this particular method over here, okay. So we already saw that whenever there is no matching method found, the arguments can be promoted in this particular way, okay. So I'm just going to try and simulate this particular scenario over here wherein I pass let's say I'll pass a long value, okay. So I type in 10l, okay, so this is nothing but the long value, okay. Now I'll try and run this program, okay. So the ideally the output should be, since I am passing the long value, what compiler does is it checks for the match, okay, but it doesn't find a match, so it tries performing the automatic promotion as per this particular rule, okay. Now since we have passed long over here, it tries promoting long to the next level, which is float, okay, and it checks if there is a matching method for float argument, and it finds the matching method and it executes this particular method which prints float argument, okay. So let's run and see the output if we are correct. And we are absolutely correct as per this particular rule, okay. So we see float argument getting printed. So what happened over here is, since we passed a long value over here, okay, it checked for the matching type. So the compiler didn't throw an error immediately. It checked for the matching type first, okay. Then it tried promoting it to the next possible value, okay. So it tried promoting to float, okay. We found the matching type for float, and what compiler did is it executed this float version, okay. Now, if for example our class didn't have the float version, okay, then the compiler might have tried promoting this to the double value, okay, and it might have done a search again, okay, that do we have a version with the double as a parameter, okay. And if in case it would not have found the double matching, okay, method, then it would have thrown the error, okay. So this is how automatic promotion works in Java, okay. Let me give you one more example, okay. So automatic promotion rule dot m1. Now let's say I pass a character over here, okay. What do you think would be the output over here? Would it throw in compile time error, or will it print something else, okay. So I don't know if you have guessed it correctly, but if you pass character, it tries to find the match, okay. It doesn't find a match, okay, because we don't have a overloaded method with character value, okay. Then it tries promoting to the next level, which is integer, and it finds a match for integer, and it prints this particular version over here, okay. So let me demonstrate this by running this particular code over here, and there you see the output. You see integer argument getting printed, okay. So this is an important interview question over here, okay, that if I pass this particular parameter over here with the character value, what is that it will print. So the next possible promotion for character is integer. So this you're supposed to keep in mind, because my students have been repeatedly asked this particular question in the interviews. So the next possible automatic promotion is this. So this is also one type of automatic promotion that is possible in Java during overloading when there is no matching method found, okay. So byte can be promoted to short, which can in turn be promoted to integer, long, float, and double, okay. So this is also one more way of Java doing automatic promotions to find the matching type of the argument. So let me give you an example of by passing a double value, okay, as a parameter, okay. So what I'll do is I'll call automatic promotion rule dot m1, and I'll pass a double value, okay. Now you see over here double cannot be promoted further, okay, and neither we have defined a version of m1 with double as the parameter, and that is the reason why compiler is throwing an error that cannot resolve m1 double, okay. So this line throws an error, so I'll just comment it, okay. So this is how automatic promotion works in Java, okay. I hope you got a clarity of this particular rule over here, okay. So whenever there is no matching type, okay, whenever Java finds that you are calling an overloaded method which doesn't have a matching type, then compiler doesn't throw an error immediately, okay. First it tries performing these automatic promotions, okay, and it tries to find the matching type by doing these automatic promotions, okay. And if compiler doesn't find the matching type even after doing the automatic promotion, it throws the error, okay. So this is a very important rule, and you guys please memorize this. This is also being repeatedly asked in interview to my students, and it's a very important interview question. So I'll pause this video right now, okay. We'll continue with the next rule in the next lecture. Thank you. Hello guys, welcome back. So in this lecture, we are going to continue with the rules for method overloading in Java. Okay. So in last lecture, we discussed around 4 rules. Okay. We also took a look at how Java performs automatic promotion. Okay. When it doesn't find the matching method. Okay. So let's go further and understand the remaining rules in method overloading in Java. Okay. So the next rule says, while resolving overloaded methods, compiler will always give precedence for child type argument, then it will check for parent type argument.
So what does this means? So this means that whenever you have overloaded a method, okay, and there are two versions of the method with so one has the parent type of the argument and another one has the child type of argument. Now both are the match for this particular method call, okay. Now in that case, compiler will always prefer the child type of the argument and not the parent type. Okay, so let me illustrate this with an example. So we'll hop on to our IDE. Okay, I'll create a new file over here which says, okay, child parent overloading. Okay, and now over here I have created a public static void main method. Okay, and I will create a method over here which says m1. Okay, and I'll pass the string version. Okay, so we have string str. Okay, and system.out.println prints string version. Okay, now I'll create one more method over here. I'll overload m1. Okay, and what I'll do is, as a parameter, I will pass the parent of the string, which is the object class. So this particular version of the method accepts the object class object as the parameter. Okay, so object version. Okay, so now let's try calling the above overloaded methods. Okay, so I'll create the object of this particular class over here. Okay, and then I'll try calling the object version first. Okay, so new object. Okay, and I'll run this code. You'll see the object version getting printed. Okay, now let's try passing the string version. Okay, so I just passed string over here. Okay, now string version matches with this particular version also of the method. Okay, and it also matches with this particular version of the m1. Okay, now the reason is because the string that we have passed is also object type, right? So it matches with both this particular method over here. Okay, and as per the rule, the precedence to the child type is always given above the parent type. Okay, which means as per the rule, string version should get printed. Okay, so let's try running this program and see if we are correct. And that is what the output you see that the string version gets printed. Okay, so just remember this rule that whenever you are overloading methods, okay, compiler will always give precedence for the child type of argument. Okay, and then it will check for the parent type argument. Okay, so now let me test one more scenario over here. Okay, so what happens if I pass null over here? So what do you think will be the output? Will it be the object version or the string version? Okay, so if you guessed it's the string version, you are absolutely correct. Okay, so compiler will take null and it will call the string version. Okay, so this is about this particular rule over here. Okay, so let's hop on to our next rule. Okay, so the next rule says, while resolving overloaded methods, if two parameters are at the same level, then there will be a compile time error. Now, what does at the same level mean? So let me give you an example. So string is a child class of object, okay, and string buffer is also a child class of object, and that means they both are at the same level. So they both are the child classes of the object class. Okay, so if you look at the hierarchy, they both are at the same level. Okay, and as per this rule, if you are overloading methods, okay, and the two parameters are at the same level, then the compiler will throw an error. Okay, so let me give you an example. So I'll hop on to our id. Okay, and I'll create a new class. Okay, which says same level rule. Okay, and I'll press enter. Okay, what I'll do is I'll again create a public static void main class, okay, and I'll define a method called public void m1, okay, and I'll again copy the same code, okay, and now I'll overload this. So one with the string version, okay, str, okay, string, and so ut string version, okay, and here I'll pass in string buffer version, okay, and I'll type in string buffer version, okay. So now what I'll do is I'll try calling these overloaded methods over here, okay. So it's same level rule is equal to new same level rule, okay, and now I'll try calling m1, okay. So if I pass string, for example, let's say name I passed, okay, it will obviously call the string version, okay, because there's an exact match, okay. So it calls string version. If I try calling the m1, okay, okay, and new string buffer, okay, and I passed in name sb, okay, and I run this program, obviously it's an exact match with the string buffer version, and that is why string buffer version is getting called, okay. Now let's uh, let's try calling by null, okay. So if I pass in null, like null can be satisfied by both a string version and the string buffer version, okay, but over here compiler throws an error. Now the reason for this is because string and string buffer are on the same level in the hierarchy, and that is why compiler can't decide like which one to call, because null matches with the string version, also with the string buffer version, okay, and since both are at the same level, there's a confusion, and hence compiler says that ambiguous method call, okay. So that is what it says, okay. But this particular code, like when we tried calling null by passing null parameter, okay, in a previous rule, which was child parent rule, okay, in that particular rule it was also matching with the both version, so it was matching with the string version and also with the object version, but the object version was not preferred by the compiler, okay. Compiler called the string version because as per the rule it is supposed to prioritize the child type over the parent type, okay, and that is the reason compiler didn't throw an error. It just matched with the string version and executed the code, okay. But over here compiler is not able to decide because both are at the same level, okay, and that is the reason why it throws a compile time error, okay. So I'll just comment this line of code, okay. So that is what this rule says, okay. So I hope you guys understood this particular rule. I'll pause this lecture now because it's getting a bit longer, and we'll continue with the rest of the rules in our next lecture. So I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to take a look at the next rule for method overloading in Java. Okay. So the next rule says that in overloading, method resolution always takes care by the compiler based on the reference type. Now, what does that mean? So I'll hop on to our project ID, okay, and I have already created a class over here called child parent overloading dot java, okay. So we'll write a sample code to understand this particular rule over here, okay. So I'll first create the main class, okay, okay, and then I'll have a main method over here, okay, inside, okay. So now to understand this particular rule, we have to exhibit an inheritance relationship over here. So I'll simulate a inheritance relationship, okay, class A. I'll define two very simple classes, okay, and class B extends A, okay.
Now these are the two classes exhibiting inheritance relationship. Okay, now I'll define two methods over here, okay, which will be overloaded methods. Okay, and they'll accept the parameter of this A class, and the other method will accept the parameter of B class. Okay, so it will be public void, okay, m1 and A. Okay, and I'll print in over here parent. Okay, because this is the version with the parent object. Okay, I'll just duplicate this code over here. Okay, and here I'll pass B class. Okay, object of B class, and I'll print in child. Okay, now what this rule says is, in overloading, method resolution always takes care by the compiler based on the reference type. Okay, so first we'll create the object of child parent overloading class over here. Okay, so creating this particular object will enable us to call these both overloaded methods. Okay, and one more thing I would like to mention over here, that these two methods m1, okay, and m1 are overloaded since we are passing the object of different classes. Okay, different classes as in they both have inheritance relationship, but still they both are different. Okay, so child parent overloading. Okay, child parent overloading is equal to new child parent overloading. Okay, and I will now create an object of a class first. Okay, a is equal to new a. I'll try calling child parent overloading dot m1 with a as an object. Okay, and now I'll try and run this program. So the output for this will be parent. Okay, because we are passing the object of a class. Okay, and it should print parent, and that is what it prints over here. Okay, so this version of the method will be executed. Okay, when we pass the object of a class. Okay, now I'll create the object of B class. Okay, in a similar way. Okay, and I'll try calling this particular method again with the with B as the parameter. Okay, okay, I pass. Okay, and I'll run this code over here. It should ideally print parent and then child. Okay, so there we see the output. Okay, so this particular version of the method call with B as the object type calls this one. Okay, so we are clear over here. Okay, now what I'll do is I'll create the reference object of the A class. Okay, A is equal to AB. Okay, now I'll assign the reference of A class with the object of B class. Okay, and in object oriented programming, the object reference of a parent class can hold the object of child class. Okay, and you will notice over here that compiler is not throwing any error over here. Okay, now what I'll do is I will try to call the m1 method with this ab as the parameter. Okay, so child parent overloading dot m1 ab. Okay, so now this is a tricky situation wherein the object reference variable is of the class A type, and the object that it's holding is of B type. Okay, and A and B over here exhibit parent child relationship or inheritance, wherein B is the child class of A. Okay, I'll try and run this program. Okay, let's see what the output looks like, whether it calls parent class or child class. So here we see the output, and we see that the version with the parent object is getting called of m1. Okay, so that is what this rule says. Okay, so in method overloading, method resolution always uh, is always taken care by the compiler based on the reference type, and the reference type over here is of the A type. Okay, the object reference is of the A type, but the object that it's actually holding is of B type. Okay, so compiler doesn't care what it's holding. Okay, it will call the method, or it will resolve the method based on the reference type. Okay, and that is what this rule says. Okay, so I hope you guys understood this particular example and this particular rule. Okay, if you have any questions, feel free to ask me in Q&A section or via direct messaging here. Okay, so let's take a look at the next rule. Okay, that is related to where arg methods. Okay, so the next rule says that where arg methods will get least priority. Okay, if there is no method matched, only then where arg method will get the chance. Okay, so this rule says that whenever you are doing method overloading and one type of method is of type where arg, okay, then that particular method will get the least priority. Okay, but others will be preferred first. So let me first tell you, I'm not sure if you guys are already aware of where arg method, but I'll just take some time to explain that particular concept to people who don't know this. Okay, so to explain the where arg method, I'll hop on to our ID. Okay, and I'll create a new class over here. Okay, called where arg method. Okay, I'll press enter. Okay, yes, and over here I'll have a main class. Okay, and I'll explain to you the syntax of the where arg methods over here. Okay, so let's say you face a scenario while doing software development wherein you want a method but you are not sure the number of parameters that you are supposed to pass in that particular method. Okay, so in that case you can create a where arg method. Okay, so where arg method just gives you the flexibility to pass any number of arguments, okay, in that particular method, and this is how you define it. Okay, so you start with access modifier. Okay, then return type. Okay, method name. Okay, and then data type. Okay, with three dots. Okay, and you have open curly brace and close curly brace. So basically this is the syntax of where arg method. Okay, over here. So I'll just create one method of this type for you. Okay, so public void. Okay, we'll call it m1 only for the sake of simplicity, and over here we'll have integer, three dots, and I. Okay, so this is nothing but an example of where arg methods. Okay, I'll pass in I'll just print in where arg method. Okay, now over here I'll try calling this particular method m1 over here, and I'll create the object first of this particular class. Okay, and then I'll try calling this particular method m1. Okay, so I'll pass in 10 first. Okay, and I'll run this particular code. Okay, it should ideally print this particular line over here. Okay, and that is what it prints. Okay, I'll again call this particular method. Okay, but this time I'll pass in two arguments. Okay, and I'll run this code. It should again call this particular method over here. Okay, and that is what it does. Now even if I pass three arguments, it will call the same method. Okay, and one more thing to note over here is where arg method can also be called with zero number of arguments. Okay, and if I run this, it will print where arg method three times. Yeah, so this is nothing but the concept of where arg methods. Okay, it just means a method with variable arguments. Okay, so where arg basically is a short form for variable arguments, and this concept was introduced in Java version 1.5. Okay, and it was introduced to give programmer or software developers the flexibility of defining methods with flexible number of arguments or with different number of arguments. Okay,
So as you can see in this example that we have written over here, we can call m1, okay, with a different number of integer values, okay, and the compiler won't throw an error unless and until the arguments are of integer type. Now if I try to pass in an argument with a different data type than integer, the compiler will throw an error. Okay, so compiler won't throw an error unless and until you are passing integer. Okay, and it's okay if you are passing 1 2 3 or any number of integer arguments. Okay, so this is the concept of where arg methods. Okay, now jumping back to our rule, it says where arg method will get the release priority, that is it will be executed only if no method is matched. Okay, so now what I'll do is I'll overload this particular method over here. So to understand this rule, since it's a method overloading rule, we will have to overload this method, which means we'll have to define one more version of m1. Okay, so m1 integer I, and I'll just print in not where arg method. Okay, now in this particular example, before we defined this version, or before overloading m1, whenever we passed one argument, okay, compiler or JVM called this particular method. Okay, but now since we have overloaded this particular method with a version of one argument, okay, one integer argument, okay, for this method call, this particular method will be executed, like this particular version will be executed. Let's see the output. Okay, so there you see the output. Okay, so for this particular method call, okay, where arg method, okay, got the least priority. Okay, so what compiler did is it found a matched for this particular version of m1 with one integer argument. Okay, and that is the reason why it called this particular version, because as per the rule of overloading, where arg method gets the least priority, okay, in method resolution. Okay, and that is what this rule says. Okay, so now if I define one more version of m1 with two integer arguments, compiler will call that particular version over the where arg version. Okay, so let me show you that as well. Okay, so integer j. Okay, I'll type in with two args. Okay, and I'll run this particular code, and there we see the output. Okay, so you can see that clearly the version of where arg method, okay, has the lowest priority, okay, in method resolution, and that is what this rule says. Okay, so where arg method will get the least priority in method overloading. Okay, so that's about the rules for method overloading in Java, guys. So these are very important rules, and you should remember this whenever you are doing method overloading. Okay, and the some of these rules are very important from interview perspective as well. Okay, so if you guys have any questions, feel free to reach out to me. I'm always there to help my students to do the best. Okay, I'll pause this video for now. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to discuss about constructor overloading in Java. By the end of this lecture, you will have a better understanding of how overloading concept can be used with constructors in Java. Okay, and we will also do a sample program which will help us understand this concept even better. So let's get started. So constructor overloading is nothing but a scenario wherein you have multiple constructors with the same name in a class, but with different types of arguments. Okay, so let me illustrate this to you guys with the help of an example. Okay, so what I'll do is I'll create a, I already have a project over here called constructor overloading. Okay, I just created this project, and I'll create a Java class called constructor overloading. Okay,
and I have a main method over here. Okay, so it's public static void main. Okay, and within this class constructor overloading, I will define a constructor. Okay, public constructor overloading. Okay, this is an constructor with one parameter. Okay, integer a. Okay, I'll create one more constructor. Okay, which is which has two parameters. Okay, so integer a, integer b. Okay, and so this is basically having two constructors with a different set of arguments. So basically one constructor has integer argument, only one integer argument, and another constructor has two integer arguments. Okay, now let's take a look at the object creation process. Okay, so I created an object. Okay, I'm writing new. Okay, constructor overloading. Okay, now it is asking me to pass some arguments over here. Okay, so if I pass 4, okay, the error goes away. Okay, so empty constructor is a invalid thing over here, so basically it's throwing an error. Okay, if I pass one integer, basically our definition of this particular object creation matches this particular constructor over here. Okay, if I pass two arguments, okay, it matches this particular definition over here. So basically this is nothing but the concept of constructor overloading. So here we have two constructors already defined with the same name but different set of arguments. Okay, so constructor overloading gives us fair flexibility, okay, wherein we want to initialize objects with a different set of parameters in a different way. Okay, so if I want to initialize this particular object in some way when there is one argument passed, I will define one constructor with a single parameter. Okay, and if I want it to be initialized in a different way, okay, when two arguments are passed, I'll define a constructor with two arguments. Okay, so this is nothing but the benefit of constructor overloading in Java. It is pretty much similar to method overloading. Okay, not much of difference there. Okay, but it's an overloading concept applied to constructors. Okay, so basically in this lecture we learned what is constructor overloading, and we also took a look at one of the examples, okay, which helped us understand this concept even better. So I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to take a look at method overriding in Java. Okay, and in this lecture we are going to understand what is method overriding, and we will also write a sample program which will help us understand this concept even better, and we will also understand some of the terminologies associated with method overriding in Java. So let's get started. So what is method overriding? So method overriding is applicable in inheritance. Okay, it's a concept wherein the child class provides its own implementation to a method defined in the parent class. Okay, so if you have a method in parent class, let's say method m1, and you have a child class called b, okay, and it is not satisfied with the implementation provided by the parent class. Okay, so whenever a child class extends the parent class, the methods of the parent class are by default available to the child class. Okay, and whenever the method of parent class is available to the child class, okay, there is a possibility that child class may not be satisfied with the implementation that parent class is providing, and in such scenarios child class has the liberty to provide its own implementation to the method defined in parent class. Okay, and this particular ability is known as method overriding in Java. Okay, and this concept is applicable in inheritance because to override a method you need to have inheritance relationship. Okay, so let's take this example. Okay, so we have a parent class. Okay, and you are the child of the parent. Okay, So every parent makes sure that his or her child gets married, okay, or they at least wish so, okay. So suppose parent has defined a method called marry, okay, and they say that you have to marry Maria, okay. Now you are the child and you are inheriting your parent, okay. So in child class, okay, if you are not happy with the parent class implementation, okay, of marrying Maria, you can redefine marry method and redefine it as marry Tina, okay. Now this particular marry method in parent class is known as overridden method, okay, and this particular marry method in the child class is known as overriding method, okay. So let's take a look at one of the examples, okay, by actually writing a sample program. So let's go to our IDE. So I have already created a project over here called method overriding, okay, and I'll go ahead and create a sample class, okay. So I'll call that class as parent itself, okay, and I'll define a method over here, okay, public void m1, okay, and I'll do a system.println parent class m1, okay. Now what I'll do is we have to define a child class as well, so I'll define a child class, okay, and I'll extend this child with parent, okay, and I will define the same method over here, okay, public void m1, okay, but here I'll print in child class, okay. Now let me create a main class, okay. So method overriding, okay, and I'll define a main method over here, okay, and I will create an object of parent class, okay, parent equal to new parent, okay. Now what I'll do is I'll try calling the m1 method, okay, using the parent object, okay. Now what will happen is this particular version of m1 in the parent class will get called, okay. So I'll call it over here, I'll run this particular code. So there we see the output, okay, we see parent class m1 getting printed, okay. Now the reason for this is parent class m1 is getting printed. The reason is since parent class over here doesn't have access to the child class m1, okay, and that's the reason why parent class m1 is getting printed, okay. Now I'll create an object of the child class, okay, child is equal to new child, okay, and I'll again call m1, okay. I'll run this code over here, okay. This should ideally call the child class m1, okay, and that is what we see over here, okay. So what is happening is basically when child class is extending the parent class or when it's inheriting the parent class, it's inheriting m1 method as well, okay, but we are not happy with the m1 method implementation that the parent has provided, and hence we override that particular method and provide our own implementation over here, okay. So what we have done is we have overridden the m1 method in parent class with the m1 method in the child class, okay. And now what I'm going to do is I'm going to define a parent reference, okay, parent 1, but I'm going to pass in the child object, okay. Okay, I didn't write new method over new keyword over here, okay. Now what I'm going to do is using parent 1, okay, I'm going to call m1 method, okay, and now what should happen when you write this particular code? So over here the reference variable is of the parent class, but the object that actually this parent class object is holding is of the child type, okay. So what will happen is let's see what the output looks like. So there we see the output. Okay, so we see the child class method getting called. Okay, and so what happens over here is when you compile the code, okay, compiler checks for the object reference, and object reference is of the parent class type, and it sees that parent class has m1 method. Okay, so it compiles the code, but during runtime JVM sees that parent class reference object is holding a child object. Okay, and during execution, since JVM sees that it's holding the child object, it calls the child class m1. Okay, and hence child class m1 method is getting called. Okay, and this is nothing but the example of runtime polymorphism, or it is also known as dynamic polymorphism. Okay, and this is one of the important features of OOPS as well. Okay, so based on this example we arrived at some of the facts that we can talk about. Okay, so I'll go back to my presentation and let's take a look at some of the facts. Okay, so if you are trying to access parent class method using parent class reference holding parent class object, parent class method will be called. Okay, so here we are trying to access parent class method having the parent class reference object holding the parent class object. Okay, and when this is true, okay, parent class m1 method is called. Okay, the next fact says if you're trying to access parent class method using the child reference holding the child class object, okay, child class method will be called. Okay, and that is what we saw over here. Okay, now let's take a look at the third fact, which is if you are trying to access parent class method using parent class reference holding child class object. Okay, in that case child class method will be called, and that is what we saw over here. So these are some of the important conclusions, the three important conclusions from method overriding in Java. Okay, so let me tell you that IDE IntelliJ IDEA also has a shortcut. Okay, to generate the code for overriding method. Okay, so you can go to code. Okay, you can click on override methods. Okay, and you can select the method you want to override. Okay, so I've already overridden m1 method, hence it's not showing me m1 in this list. So what I'll do is I'll just copy this line of code. Okay, and I'll delete this. Okay, and I'll try overriding m1 method using this particular shortcut. Okay, so you see over here m1 appearing, you click OK, it says insert override keyword or copy the Java doc. Okay, so I'm not going to do that, I'll just press OK, and you see this particular line getting printed along with some pseudo code. So I'll just delete this and I'll paste in the line of code that we copied. Okay, so this is how you also this is also a shortcut. Like if you are looking to override multiple methods in the parent class, so instead of going and typing all that code, you have this particular shortcut wherein you can just select multiple methods that you want to override and press OK. IntelliJ is quite intelligent, wherein it will generate the code automatically for you. Okay, so in this particular lecture we understood what is method overriding in Java. Okay, and why it's so important. Okay, we also understood this concept better by writing one sample code. Okay, and we also took a look at some of the facts that you can derive from method overriding in Java. I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to understand what is data hiding in Java. So let's get started. So data hiding is nothing but the way of protecting members of class from unauthorized access. Okay, now what does that mean? So if you are building an application like Gmail, okay, you will make sure that passwords are hidden from the outside world. Okay, so password is something private. Okay, and you don't want to share it with others. Okay, and you'll make sure that you will declare password as private. Okay, and this is nothing but you are doing data hiding, okay, in your program. Okay, even if you consider the example of a bank account, okay, you would want the account balance to be hidden from the outside world, and hence you have to make sure that account balance is hidden. Okay, now here is how you implement data hiding in Java. So data hiding in Java is implemented with the help of the private keyword. Okay, so here in this example I see account balance is hidden from the outside world. Okay, and no one uh, outside of this class account can access account balance. Okay, whereas account balance is only accessible from this particular method called get balance. Okay, and in get balance method you can write whatever rules you want, okay, to return the account balance. Okay, and this is nothing but the example of data hiding in Java. The advantage of data hiding is nothing but the security. Okay, it prevents unauthorized access to your data members. Okay, and this is the biggest advantage of data hiding. So this is nothing but data hiding in Java, guys. I hope you guys enjoyed this class. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture, we are going to talk a bit about abstraction in Java. Okay. And by the end of this lecture, you will have a better understanding of what is abstraction in Java. And we will also take a look at some of the advantages of abstraction. So let's get started. So let's consider an example of ATM. Okay. So when you visit your ATM, you have to swipe your card. Okay. Now after swiping the card, you can see different options or different functions that you can do on the screen, like withdrawing the amount, checking your balance, etc. Okay. Now in this case, whenever you swipe the card, ATM validates the user for authorized access. Okay, and you are not aware of which server, against which server the bank is validating this information. Okay, and the reason for this is it's not important for the user to know this information. Okay, you are also not aware like what query in background ATM is using to validate you as a user. Okay, because from the user's perspective it's not important for you to know these details. Okay, so you are only required to know what this ATM does. Okay, what are the core services that the ATM offers to you. Okay, and that is what you exactly see on the screen. You will see different options to withdraw your amount and to check the balance and to do other functions. Okay, but the point here is ATM only shows you the set of services, okay, that you can perform using the machine. Okay, it doesn't give you the background information of servers and the queries that are running in the background. Okay, so here the internal implementation details are hidden from the user, and this thing of hiding the implementation details from the user and highlighting only important stuff is known as abstraction in Java. Okay, and there are various benefits of abstraction in Java. Okay, we'll take a look at some of the advantages over here. Okay, so the first advantage is of security. So since we are hiding the implementation details of the system, okay, we achieve security wherein the user doesn't know the background information and what happens internally, okay, to perform certain operations. Okay, and hence security is one of the advantages of abstraction. The second advantage is the ease of implementation. So since we are not aware of the internal working of the system, okay, it becomes very easy to change some technology and to do some changes in the background that user is not aware of. Okay, so basically let's say tomorrow a new programming language comes in the market. Okay, and if you don't know which programming language your system is built in, it becomes very easy to change the language from the background. Okay, like you can just replace the code from the background without user even knowing it. So that is one of the benefits. The next benefit is improves maintainability.
and again, since the user is not aware of the background working, it's very easy to maintain the code. The next benefit we have is the ease of use. Okay, so system, it's very easy to use systems that have abstractions. Okay, so basically imagine a scenario wherein you have to know the programming language or the server information before using the ATM. Okay, this way no one will ever learn to use the ATM. Okay, because they have to first learn programming and also remember the server information against which they are validated. Okay, and this is also one of the advantages of abstraction, wherein this internal details, internal working of the system is hidden from the user. So these are the four advantages of abstraction. Okay, you can implement abstraction in Java using interfaces and abstract classes. Okay, so interfaces helps you with the partial implementation or the partial abstraction, and abstract classes basically offer you full abstraction. Okay, so this is about abstraction in Java, guys. I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture we are going to talk a little bit about the most important object oriented principle, which is nothing but encapsulation. Okay, and by the end of this lecture you will have a better understanding of what is encapsulation and what are its advantages. So let's get started. So if you are not well, then you must have taken a tablet in the form of capsule, which has the necessary ingredients to cure you. Now here you don't know what ingredients this capsule has, but you know that it will cure you. And a mixture of all these ingredients, okay, makes sure that you get cured. Okay, now encapsulation in a similar way is binding the code and data together in a capsule to hide the complexity of the class. Okay, so here in this example, this class account does the job of encapsulating the data members and the method into a single unit. Okay, encapsulation has very less to do with the access specifiers, that is public, private and protected. Okay, in encapsulation, members inside the class can be private, public or protected. The private member of the class are accessible to the objects of that class only. Public members are accessible to the objects of the class as well as they are accessible from outside the class. And also encapsulation also helps the end user of the system to learn what to do with the system instead of how it must do it. Okay, now one more rule about encapsulation is if any component follows data hiding and abstractions, okay, such type of component is known as encapsulated component. Okay, so this particular statement is true for encapsulation, wherein data hiding plus abstraction is equal to encapsulation. Okay, now let's consider an example of the ATM machine wherein you see the button to get balance and withdraw money from the account. Okay, now here in this particular example we will hide the complexity of withdrawing the amount and getting the balance from the end user. We have also declared the variable as private. Okay, so this particular balance variable is private. Okay, to implement data hiding. Okay, so for the end user he has to just press the button on the ATM screen to perform the operations, and hence this is an example of encapsulation. Now let's take a look at some of the advantages of encapsulation. Okay, so the first advantage is security. So encapsulation provides security since you can validate the access via methods and perform operation in the correct way. It also gives you a better flexibility. Okay, as in we can make variables of the class as read only or write only depending on our requirement. So if we want to make variables read only, then we have to omit the method that sets the value of that particular variable. Okay, next advantage would be enhancement becomes easy. So it's very easy to enhance the underlying operations, okay, with encapsulation.
And the fourth advantage is improved maintainability of the application. Okay, so this is about encapsulation, guys. So in this lecture we understood what is encapsulation and what are the advantages of encapsulation. Okay, so I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you. Hello guys, welcome back. So in this lecture I'm going to explain what are getters and setters in Java. So by the end of this lecture, you will have a better understanding of the importance of getters and setters and how they are helpful in Java. So let's get started. So I have already created a project called getters and setters. Okay. Now what I'm going to do is I'm going to create a class called account. Okay. And I'll define a variable called integer balance. Okay, and I'm going to make it private. Okay, because balance is something I don't want anyone outside this class to call. Okay, so I'll make it private to this particular class. Okay, now I'll create one more method. Okay, which is public. Okay, void set balance. Okay, and I'll accept an integer parameter. Okay, integer a. Okay, or integer balance, let's say, and I'll set this dot balance is equal to balance. Okay, so basically what we are doing here is we have created a class called account and we have a variable called balance and we have a method called set balance. Okay, which has integer parameter. Okay, and this particular balance is assigned to this particular variable over here. Okay, now this method called set balance is public to the other classes. Okay, so if we are allowing anyone to set the balance of the balance variable, okay, of the account class. Okay, and this particular method over here is known as a setter because using this method you can set the balance. Okay, now I'll create a getter over here. Okay, and getter is nothing but a method that returns the value of this particular variable called balance. Okay, because balance is private and if we have to access balance, okay, from outside the class we need a getter over here. Okay, so I'll type in public and you can see that IntelliJ IDEA is smart enough to suggest this particular method to me, integer get balance, and I just do that and it auto types the entire code over here. Okay, now you can call this particular get balance method from anywhere to get the balance of this particular class. Okay, and this particular method get balance is known as a getter. Okay, now you might be wondering like what is the benefit of doing this, like why would I set a variable private, okay, and define getters and setters to access this particular variable. I can just change this access modifier to public and let everyone access it. Okay, so the benefit of doing this, okay, is having a control on who can access. Okay, so let me give you an example. If I want only authorized users to access balance, okay, I will have some validation over here. Okay, like I'll define over here like if user is equal to authorized. Okay, okay, only then set the balance. Okay, so I can set this, I can write this type of logic over here. Okay, and have control on who can access this particular private variable. Okay, and this gives me the flexibility of defining on who can set the balance of this particular class. Okay, and the same goes for the getter methods as well. Okay, so I can define, I can write some validation logic over here and control the access to balance. Okay, and these are the benefits of having getters and setters. I would like to show you one more shortcut over here. Okay, so I'll delete this code over here. So if you have defined a variable, okay, and if you want to generate getter and setter for this particular variable, you can just go to code. Okay, you can click on generate. Okay, and this is a shortcut like command N on Mac. Okay, so if you just click on generate, okay, it will tell you generate constructor, getter, setter, and all the other options. So I'll click on getter and setter. Okay, and I'll select the variable over here. Okay, like this particular variable,
balance is what I want to generate for, and I'll click on OK, and it automatically generates the getter and setter for me. Okay, and this is one of the shortcuts. And if you have a class with lot of private variables, okay, you can use this particular method to uh, make your life easy. Okay, so these are the benefits of having getters and setters. Okay, I hope you guys enjoyed this class and found it valuable. I'll see you guys in the next class. Thank you.